Hello, beautiful people, and welcome to NorthSec Tech Days event 2023 winter session. Hey, we have some applause here. So, first thing first, we have a beautiful event today. We have somewhat around several people in here. If you're watching us online and you are in Cyber City, please join us at Building B in front of the iLunch. We have some coffee and snacks in there, and you have the ability to network with people. I'm extremely happy for this event because it's the fifth one, and we had around 20 applications for it. We selected only 12 for today, but for all those people who applied for this session, just bear with me, and you can use these applications for the summer session as well. And if you have some ideas, and if you want to try the stage, always you can use the opportunity and to apply for the summer session as well. We have a special NorthSec Tech Days channel that we're going to use for the questions in the audience. And I'm going to introduce the speakers there and use the thread for the channels. I'm going to try to ask. If you don't have any questions, we'll not have any questions. I'm going to brainstorm on the fly to ask them as well. A little bit about the agenda today. We have pretty much to cover. And we're going to start with our first-time external speaker, keynoter, Laurynas. Thank you, Laurynas, for coming. He's going to talk a little bit about the MySQL internals and how it works and what to use and what not to use. Then Lukas is going to jump into the CPU stuff and how to make it more performant. Benas talk about the NordVPN stuff and libraries and how we are using them between the apps, and Povilas will gonna end this little section with a little bit of LLMs and how to create them on your computer and how to use them. Then we're gonna have a lunch break. You can use the lunch, by the way, or other other places that we have around here. And we're gonna have a second section. We're gonna talk about full stack automation. Then Ignas will deep dive into AI ethics because it's a really hot topic right now. Then Herman will talk about our web architecture and its history and how it's changed on nordvpn.com. And Alina will deep dive a little bit into ownership, accountability, and failure, how the teams works in general. Then another break. And the last section, but not least, about the ISPs. Dominika is going to talk about TLS, and not only TLS, and what ISP sees or not sees when you're using it. Then his guys and girls gonna talk about a little feature that we are using in threat protection and how we're catching 0 days phishing attacks in there. A lot of machine learning, I heard. Christina, as always, will present a little bit about the data and this time anomaly detection and how we use it at NordVPN. And Mindaugas have a really extreme talk about the passkeys and one of the heaviest talks in here, but like a surprise for you guys, like we left it the last. Then we're gonna have a celebration and after party with Beer Friday. It's gonna be fun, so stick around, use the opportunity to talk with people, ask a lot of questions, and just enjoy the event. And now I would like to present our one and only external speaker, Laurynas Biveinis, and he's going to talk about MySQL internals. Please take it away.
Well, thank you for inviting me over. My name is Laurynas, and I'm going to talk about MySQL today. MySQL, as you probably know, is world's most popular open source database, which makes it different from PostgreSQL, which is world's most advanced database, and SQLite, which is most widely deployed database in the world. Anyway, so I've been working with MySQL for the last 10 years out of 12 years. I've been working on its source code. I did that in Percona, and now I have my own little company doing that. And today I'll be talking about internals, but while I would love to talk about the source code, I cannot do that in 30 minutes and cover MySQL in any reasonable depth. So what I'm going to do instead is that I'm going to talk about its subsystems. And hopefully it will help you understand what are the recent changes in MySQL and what's in the future for MySQL, and if MySQL is in your future, how should you prepare for it? So, however, I would like to focus on the recent changes in MySQL, and that's not a trivial question. Here is what changes are recent and what changes are not recent. So the first thing I would like to discuss today is the MySQL release model. It has changed twice in the recent history, and some of the changes are for better and some changes are for worse, but you have to be mindful of them. So before 2016, MySQL was this open source product which had several stable branches, the older stable branch, the newer stable branch, and sometimes it had a development branch, which then became stable branch, and the oldest stable branch fell out of maintenance, and the cycle repeated. Then in 2016, something happened, is that 8.0 was released, and with 8.0 came something known as a rolling release model. So there was no newer development branch, and all new features were getting delivered in the 8.0 in patch level releases. Sometimes backwards incompatible, sometimes leaving you with no way to downgrade if you don't like what you see in the newer release. Well, luckily for us, Oracle, the MySQL developer, listened to user feedback, and just a few months ago, a new development model was announced, and now we have the following situation. 8.0 becomes a bug fix only branch, and finally the semantic versioning in the patch level release number stopped lying about it being patch level, and then we have occasional innovation releases, and sometimes we'll get a long-term support release. So right now, in this graph, we are at the point after 8.2.0, which was released like 4 weeks ago. So with this, now we can go back to that question. So what are recent changes and what are not so recent changes? When I was working in Percona, we used to do these user surveys, and we asked what version of MySQL you are running in production. So when 5.6 was the most recent release, users were running 5.0, 5.1, 5.5. When 5.7, they were running mostly the same, but the oldest releases were having slightly reduced usage. So users tended to run old releases, to be slow in deploying new versions, and I would say that's probably good for them, except when the release has end of life, and then that becomes a support issue. And now with the 8.0, we had only one version number to consider. 8.0, that's it. Is it new? Well, it depends. 8.0.10 is probably not new. 8.0.35, it is new. But at least for me, they both kind of sound new. It's 8.0, so it must be new. And in any case, as of last month, it shouldn't matter, even because 5.7 now is reached end of life, and 8.0 is the only release you can be running. So the only question is which patch level. But now we have 8.1 and 8.2 releases in this year, and these are really new. But you shouldn't be running them in production because they are not production quality. So so I'm going to talk about 8.1, 8.2 as a sort of future changes releases, and the recent 8.0 going back in time as needed. But maybe I could get a show of hands. What are you actually running? Are you running new 8.0, old 8.0, so new 8.0? We don't know. So it's what's on the cloud, right? Are you running MySQL at all?
Yes, we do.
Good, but you don't know which release, or somebody's running MySQL for you. Okay, that's good enough if it works for you. So let's do an overview. So this is in a very broad strokes how MySQL looks like internally, and let's do an overview first before going into some of the selected areas deeper. So let's go from the top to the bottom, because this way roughly corresponds to how query is executed. And let's see, so we start with the connection management. So all MySQL versions had a lot of overhead there. So this was mostly fixed in 5.7 and a little bit in early 8.0. And if you are inclined and the default thread per connection model does not work for you and you don't have MySQL router or proxy in the front, then you can run Threadpool plugin as well if you want. Then once connection is established, the next thing which happens is that it goes to the query parser. And the parser has received a lot of work again in 5.7 and early 8.0 to rewrite it properly, because well, I shouldn't be talking about the source code, but I can say that the parser grammar is 20,000 lines long, and it's not because SQL grammar takes 20,000 lines to describe it, but it's because there's a lot of semantic source code actions intermixed in the grammar, which shouldn't be. So they are working to split them properly and to enable new SQL syntax and to, well, make the source code maintainable. So that is good. Then the main thing below the SQL parser is, of course, query optimizer and executor. This one got a lot of changes in 8.0, and I'll look into some of them in a slide later. But we can look sideways that we have metadata logging, we have data dictionary, and we have, of course, very important binary logging and replication. So in leading up to this event, one of the questions I got was, what about metadata logging? Can we get rid of it? Will Oracle get rid of it? Well, the answer is probably no, because it's kind of useful. Because in the days before metadata logging, in 5.1, where it was kind of done by storage engine table level locking, there were all kinds of correctness issues, because you could basically drop and rename objects in the middle of access, and there was nothing to prevent that. So here comes the metadata locking. Maybe it should get its overhead reduced. I don't know. I didn't see the overhead. But I would be happy to discuss this question offline later. So next thing, big thing in 8.0 is data dictionary. Legacy MySQL, up to 5.7 inclusive, had these form files and so on. So all the table information and all the other object information were stored in separate files on disk. So one of the big rewrites in the early 8.0, one of its major selling advertised points was that they rewrote the data dictionary to be transactional and to be stored in a DB, which is transactional storage engine. So this improved crash safety for create table and other DDL statements dramatically, and removed all kinds of old code and made all kinds of code in the server better. Then we also have, well, binary logging and application. There will be a slide for that. So now if we go down, we have this handler, storage engine interface, which sort of kind of halfway allows the server to not know what storage engine it is using underneath it. And it can be in a DB, it can be something else. So some people say that this is the most important innovation early MySQL did, and it ensured its longevity, which is, I would say, true, because if MyISAM was integrated into MySQL, probably today we'll have a bigger write or no MySQL. So now the storage engines. Another question also got in preparation for this was about performance schema. which is a technical storage engine, and which is what MySQL provides these days for monitoring and observability. So when Performance Schema came out first in it was 5.5, but in 5.6 it was usable. There was a lot of pushback from community because it had a lot of overhead, like 10%, order of 10% overhead for simple queries. So community complained loudly, and what happened was that Oracle did what it could to reduce that overhead, and things are better now. I don't know if they are perfect. I don't know, maybe you can tell me. So finally, the actual storage engines. InnoDB. InnoDB is the flagship storage engine in MySQL, and of course, we'll be talking about its recent changes in a separate slide. One thing is that after implementing a lot of features, it is some sort of impression that maybe it is not getting as many new features delivered recently, which is hopefully a temporary lull or something like that, because it's InnoDB is one of the main reasons to use MySQL, at least up until recently. But we'll get to InnoDB changes later as well. So another thing is we have a temp table, a new storage engine, which is used for Query Optimizer internally. It replaces new legacy memory table uses for temporary optimizer tables when you have dynamic length character columns, things like that. And we have a third-party storage engine, Myrox. So this one is pushed by Facebook, currently known as Meta, to reduce storage space and write amplification compared to InnoDB at the cost of worse read performance. I'll try to get to that later as well. And we have a bunch of other storage engines such as Memory, CCV, and NDB, which is the whole product altogether. Now, some of the storage engines should no longer be used. This includes MyISAM and TokuDB. So MyISAM was, of course, the original MySQL storage engine, and it's still maintained, but you shouldn't be using it. And TokuDB, it was also write optimized like Myrox, but it didn't take off, and it's now scheduled to be end of life by Percona at the end of 8.0 lifecycle. But before we talk about any subsystems, we cannot ignore cloud, basically. And everything these days is about the cloud, and all the database companies want to be in the cloud and want to make money from the cloud. And like the MongoDB licensing issue showed, sometimes they are not happy about other companies taking the source code, running in cloud, and taking all the money. So Oracle entered cloud business. Oracle had its cloud, OCI, or Oracle Cloud Infrastructure, or something like that. And it delivered a MySQL product there, which is called HeatWave. Its major selling point was efficient analytical queries, something that MySQL itself is not familiar with, not famous for, because analytical queries are kind of very different from OLTP workloads that MySQL is usually running, and it's not optimized for that. But they did that. They did fast analytical queries, and they're advertising that. Now what happened is that now, of course, the Oracle engineering team is split between the open source server development and cloud development. And we open source users now, we are getting less of the development effort, and such is life. But the open source side is still affected by the cloud in that it has to be made cloud compatible, cloud native, and so on. And a lot of features in the server and around the server were delivered about that, for monitoring, for making configuration changes, for restarts, and so on. OK, let's go to the Query Optimizer. Again, recent changes. So very recently, 8.2.0, union operations got much better. I suspect they are using that hash join infrastructure, which is on the 4th bullet point, but I don't have the confirmations for that. So SQL standard supports union operations, so all the set operations. So I should have been saying set operations, not union operations. Yes, set operations. So union, accept, intersect, things like that. And now they are really fast and can be used in applications. Another feature was that MySQL was providing the prepared statement feature as early as 5.0, when MySQL went through the push to become an enterprise database, and that meant it developed enterprise features. The problem is it's developed in low quality, and for example, if you were using prepared statements, thinking that if you prepare a statement in advance and execute it later, that somehow it will be more efficient to prepare it once and execute many times and things like that. Well, that did not happen. It was basically a wrapper around regular execution, but now prepared statements can be executed more efficiently because they are now actually prepared once. Now, another thing is that in the Query Optimizer, they said condition pushdown got much better, which is again probably a cloud feature, because in a cloud they push down those conditions, the where clauses, parts of where clauses, all the way to remote nodes, which is more efficient. So that's good. A bit more older 8.0, but still kind of a big thing for MySQL, was a hash join. So for decades, MySQL had only one join algorithm, which was nested loops, which was fast when data was cached, but slow overrise. So now there are alternatives. I think this is also driven by analytical queries, but it's a good feature. And there was some ongoing feature as well. Now the join order between the tables can be determined much more efficiently than before, because originally MySQL could execute joins only by considering what two tables to join, and then taking a next one table to the result and continuing that. So this resulted in so-called left deep join trees. But now with a hypergraph optimizer, it can do any kind of join tree, which is again a heat wave feature. But it's present in the open source product. Replication. A big thing here is that in the future there's going to be only raw format for replication. There is probably no way around it, and you should prepare. So statement and mixed are going away, and at least Oracle took care to address some of the pains, which resulted if you try to use row with your arbitrary data schema previously, such as, for example, if you have large blobs and try to replicate them. So in the old versions, what happened is that the whole blob had to be shipped. So now they implemented delta replications and so on. So they made this more efficient. So also driven by a cloud, another feature is that it is possible to add hidden primary keys for all the tables that don't have them. So this is for cloud because they couldn't just force the users to add primary keys to their tables. They had to accept arbitrary table definitions. So if you're familiar with, say, InnoDB, that it also sort of has the same internal feature. So this is completely different. It has no relation to the same feature in InnoDB. Another very old concern about MySQL replication was that originally it was single-threaded, and they made it parallel. And when they made it parallel, it was not trivial to determine what transactions you can actually execute in the parallel on the slave. So there were several algorithms, and for some reason, they are standardizing on commit timestamp ordering. and no longer they are going to track the write sets. And I am not sure why they made this decision, but it's a decision made by them in 8.2.0. And this is, well, we will have to live with it. Finally, XA transactions, another enterprise feature, which was shipped in 5.0 and was completely unusable. So it is getting usable bit by bit. And one of these days, it's going to be to become actually usable for the first time in the last 15 years. OK, group replication. So this is new thing in 5.7 and 8.0. And they shipped one small feature that now it's possible to have asynchronous replicas hanging off group replication nodes sort of automatically, because it was always possible to have such setup, but now they just automate it and made it easy. And the most recent feature in the group replication in 8.2.0 is that MySQL router now can automatically split reads and writes by looking at your transaction and forward to the right node. In the past versions, what happened here was that you had to specify the port by yourself if you wanted to do read-write splitting, and you had to have different ports. So finally, group replication. So with the end of 8.0 rolling releases, now it finally becomes possible for the first time to deploy different patch-level versions in a single cluster. Because previously, that was kind of complicated. Now it's going to be slightly less complicated and making upgrades a bit easier. And they also shipped a Kubernetes operator, which I have no idea how well it works, but it's there. You can look at it, and maybe it's actually usable. OK, InnoDB. As I said, the InnoDB development has been slowing down a little bit, but maybe that's temporary. Maybe that's just an impression. And there are still new features getting shipped. So a very nice feature is that alter tables, add and drop columns became instant operations for arbitrary column types, arbitrary column positions in the table, and so on. So that's a good feature which many people were asking for, and which should reduce the need for online schema changes and the like, third-party tooling. We also have a redo log resizing, which is kind of the last word of the ongoing redo log rewrite in the 8.0, which happened in the early 8.0, where they made the redo logging scalable to multi-socket servers and so on. And double write, if you're familiar with that, with the torn page detection and fixing, they shipped this feature where you can have a faster double write, which will not recover your corrupted pages for you, but it will tell you that you have corrupted data pages, and you will be able to respawn the instance instead of running with a silently corrupted instance. And the most recent feature is that buffer pool online resize, which was there since 5.7. Now you can see which stage it is at. I don't know many people who are resizing their buffer pools in production, but if you are one of them, this sounds useful. So these days, probably the main major third-party storage engine alternative to InnoDB is MyRocks, which is pushed by Facebook/Meta. And the reason it is being deployed there and why it is the actual viable alternative to InnoDB is the big different trade-offs on the big free access. So you have the storage space requirement, you have write amplification for your writes, and you have read amplification for your read. So what MyRocks does differently from InnoDB is that it requires, by Facebook's data, about half less space than compressed InnoDB, which makes it about 4 times less than uncompressed InnoDB, and just 1/4 of the writes, which is good if which is good for a solid-state drive lifetime. But the trade-off is that you do more reads, and at this point, Facebook is not saying exactly how many more reads, but it cannot be 10,000% more reads. So the main difference between InnoDB and MyRocks internally is the main data structure being used is different. InnoDB is using the classic B tree used by most databases since 70s, where you have this tree-like structure, and if you want to read or write, you start from the top, you go down, 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 make changes, and you patch upper levels going higher as needed. Whereas MyRocks uses RocksDB, which uses something called log-structured merge tree, which just writes things in a sequence. And then after some time, just takes this sequence and flushes it down to the next level, which is much faster, right? But then if you want to read, you have to check all of those C0, C1, CKs, unless some optimizations are deployed. Finally, I can talk a little bit about how MySQL development is done. So it's open source product, not project. PostgreSQL is open source project. You want open source project, MySQL is not for you. Oracle is it's a steward, and it's a steward, and Oracle and only Oracle makes any decisions about MySQL, and you can ask them nicely what you want to have, and they will consider, and they will decide. So the code base is very large. Some parts are old, some parts are new, and there is a lot of effort, conscious effort, to make it better, to make it new, to make it more modern, to switch to newest C++ dialect versions and so on. But it's just a very big code base, and it's a never-ending work. So if you want to influence something in MySQL, well, essentially the only two things you can do is file a public bug in the bug tracker, and then maybe you can talk to their community managers, who are very friendly. But they will never promise you anything, and they will do their best to help you. But there is never any guarantee that they will make something happen that you need if it's not in Oracle plans. They can take patches. I've been sending them patches if for missing features, for bug fixes, which is sometimes the best way to get something fixed in MySQL, instead of filing a bug and waiting for them to fix it. But even if you send a patch, there is no guarantee that they will take it, whether they will take it, and how quickly they will take it. So that's also brings it to the overall challenges. So are they focusing on the cloud too much? Maybe. I don't know. They are focusing on the Oracle Cloud, and that's I don't know if that's very popular cloud provider. Maybe they will reconsider, but for now the development is split between the cloud and open source. Another thing is what sometimes happens is that new versions have performance regressions. And sometimes it is only a community which reports them, and Oracle itself does not necessarily catch them first. So that means that you have to benchmark all new versions. But even with all those drawbacks, it is well positioned for the future, I would say. The cloud focus, it is not debilitating for the core server. The performance regressions are findable and even fixable. So it's still a solid choice. So with this, that brings me to the takeaways. So If you're not on 8.0, after you find out what version you are running. So after you find out, you should be migrating to 8.0 because 5.7 is dead, and 8.0 is here to stay. Unfortunately, the rolling model means that patch level release upgrades are not patch level release upgrades. And you have to be careful and not use legacy features. So the more pressing business is probably SQL mode. No nasty things there, like invalidates accepted or things like that. But eventually, if you're not replicating in a row, eventually you should be. And there are many more deprecations and things like that. Finally, if the Facebook's reasons to run MyRocks also resonate with you for storage space, for reducing writes, you can evaluate it as well. Well, thank you. Any questions?
Thank you, Laurynas, for amazing presentation. Do we have any questions from the audience? Because they have a cube that they want to kick away, but I'm not gonna do it. I'm gonna come, Rytis, come on. Okay, you gonna catch it? Try.
So no questions.
It didn't happen. He didn't catch it, but he's gonna ask the question now. So.
Yeah. Can you hear me?
Yep.
Yes.
So I actually was working in the client side for a few years right now, so I'm not as familiar with the databases themselves. But as far as I know, MySQL has like this, let's say, reputation for being stable, reliable, and all that. And I kind of wanted to ask, how does the testing and like QA and all those things look like in the project itself?
So they have extensive regression test suite. They are using all the up-to-date C++ tooling, such as address sanitizers and the like. And so that's concerning correctness testing. They have all kinds of load testing tools. They're using Sysbench. That's good. Not as good as SQLite, but that's good. Now for performance testing, that's an internal setup which I have no insight into.
Okay, any other questions from the audience? Yes, Pavel.
How long does it take to build the full MySQL project?
To pull or build?
To build.
Build, okay, so yeah. So this is going to be an advertisement for Apple Silicon. So Intel Core i9, half an hour. Apple M1 Max, 5 minutes.
Okay, nice.
A little bit of difference here. We have some questions on the Slack. Are there any MySQL security features being developed or any focus on security at all?
Yes, so connection management, it uses all the SSL tunnels, and the ciphers are updated all the time, and the releases get the security fixes for OpenSSL and the like. So the binaries are rebuilt.
So basically TLS, right?
TLS, yes.
Yeah, okay. And another one, is it any mode to run in more concurrent I/O in the same time as for NVMe disks, where you can get more speed up as more I/O happen in parallel?
Yes.
Yes. Cyprian, the answer for you is yes.
This question needs a bit more specifics to make a useful answer, but InnoDB received a lot of work to be able to utilize as many IOPS available as possible, and so does MyRocks. So yes.
Okay, and the last one from me, as I understand, MyRocks was pushed by Facebook to solve the problem with a lot of writes, right?
Like I think the disk space first and write second.
And writes. So if you don't using writes, especially, you should still stick with InnoDB?
Oh, for read-only databases, InnoDB performs better if the disk space is not a concern.
Yeah. Okay, that's it, I guess, from Laurynas. Thank you very much for coming here.
Thank you.
And right now, we're going to have Lucas on the stage. Lucas, he's going to talk a little bit about the CPUs. and how to code efficiently. And yeah, it's going to be interesting talk. Shoot it away.
Good day, everyone. I am Lucas Pukenis, a software engineer from Node Security. I am working in a low-level team, and recently I was quite obsessed about low-level performance and especially how CPUs operate. And I'm going to present some of my condensed findings, and I hope you're going to enjoy it. So the small agenda for this talk is basically modern CPU 101, then it's vectorization, which is a crucial part of it, then it's a small playground, and then it's a QA session. So modern CPU 101. This is what the high-level overview of the Intel Skylake looks like. And Intel Skylake isn't like the latest architecture already, but it's the first picture I found the most easily on Google. So this is what the CPU looks after you take out it from the black box. We can see a lot of parts, and it's just a high-level overview. Actually, a lot of stuff is happening behind the scenes in those details, and some of those things are even undocumented, and those are trade secrets. Some are vendor-specific stuff, and you might find people finding all of various sort of things in the CPUs by just doing some stuff and judging based on the side effects. So the CPU can be split into two major parts, which is the front end and the back end. And I thought about inserting some JavaScript joke here. So the front end is basically responsible for fetching instructions, decoding those instructions, and feeding to the back end. And the back end is responsible for actually executing those instructions. So the back end is actually where the whole magic happens. The back end is pretty sophisticated. It knows how to do multiple stuff at once, how to manage dependencies and whatnot. So we need to discuss three terms used to describe modern CPUs, which is pipelines, superscalability, and out-of-order execution. So the pipelines is just the pipeline execution of the CPU. So instead of just taking a thing and just doing it, the CPU basically loads this thing, decodes this thing, splits this thing into multiple steps, then executes all of those steps, then writes back and whatnot. Superscalability means the CPU is physically able to perform multiple things at once. And out-of-order execution basically means that it can rearrange the stuff inside of it to execute based on the dependency graph, because each instruction is split into multiple paths. It might mean that actually we can execute some of those paths independent from other execution units. So the micro operations. Micro ops, or UOPS for short, is the smallest amount of work CPU can do in the backend. If you take an instruction, for example, like move something into the register, actually it might translate into multiple micro operations from the front end to the backend. Now the front end is pretty sophisticated. It might actually decode multiple instructions at once, split those into one stream of micro operations, and it can feed those to the backend in one cycle. And we can see the zoomed-in view of the Skylake as execution units, EUs for short, as you can see on the bottom right. And we can see an interesting thing that it contains 4 ALUs, which stand for arithmetic logical unit. And we can see 2 AGUs and 1 store data. So arithmetic logical unit basically knows how to do stuff like shift bits, do integer stuff, and whatnot. So in theory, this means that this CPU contains 7 ports, and 4 of those are ALUs. We might, in theory at least, load like 4 arithmetic instructions to execute at once for the backend. And actually, these are like optimistic thoughts, because if there are like dependencies, if you move stuff to A, then stuff to B, and then add those 2 things together, we might need to wait until the moving has ended until we can add it. We can see that we have 2 AGUs, which stands for address generation unit, and it contains 2 like load parts, load data parts. So load data is responsible for loading data, and this means that Intel Skylake is able to load to perform 2 load operations at once. And there is only 1 store data, which is for storing things somewhere. So having 1 store data is not as bad, because CPUs, like the backend, contains a lot of optimizations. So for example, if you store data to the memory, it doesn't actually mean that it stores it immediately to the main memory. It might only store it into the cache, and only then offload to the main memory, or it might even not do so. So two things when talking about instructions is latency latency and throughput. And latency is just an optimistic number of CPU cycles for the instruction to execute in case everything is ready. The data is ready, sorry. And the throughput is sort of a weird number because it basically takes the all of the micro ops of the instruction, execution pods it uses, cycles, divides one by another, and it sort of like a number, which means how many such instructions could be executed ideally in parallel. So for example, in the 0.25 throughput case, it means that the instructions, like 4 such instructions can be executed at once in the CPU. Some stuff about speculative execution and branch prediction. So the front end fetches the code from the memory, from its instruction cache, it decodes it, it feeds into the backend, and then it encounters a loop. So it encounters a loop, and it actually might execute code, as I mentioned, because of this whole splitting into the micro operations and whatnot, and it has pretty big buffer of stuff to execute. So it might offload, as I mentioned before, from the front end multiple stuff at once. So what does it do when it encounters a loop? Now it can't actually do anything because it needs to know where the branch goes. So the branch prediction kicks in from the front end, and based on the guesses from some sophisticated algorithms, it simply feeds the backend with instructions it guesses that it should execute. So in case after everything was done and the branch turned out that the guess was correct, the backend actually did useful work, which now can be fully retired. All of the things might be written and committed. In case the guess was faulty, everything needs to be flushed down, and it's not as such of a penalty because of the flushing. It's sort of a penalty of of badly used resources on the CPU backend. This is sort of a picture which shows the pipeline going from left to right, from top to bottom, which shows if a bubble appears, we can see in stage 2 decode on the clock cycle 3, if the bubble appears, it affects all the following steps. So our job when writing performance stuff is to actually minimize those bubbles. All of this stuff I just described could be considered like a guesswork. You know, you need to guess a lot of stuff, and basically just believe that it's there. However, we can actually sort of feel it. The CPUs contain built-in counters, hardware counters, and we might read those very easily with CPU instructions. And we might actually get a lot of stuff the CPU has. So this is an example from my work laptop output. So perf is a utility on Linux, which simply reports to you those events. And I can see that I can have branch misses, cache misses, instructions. And on the bottom middle, we can see stalled cycles backend and frontend. So this actually refers to the frontend and backend I just talked about. And in case the frontend wants to fetch instructions and decode those instructions, but those are not in the instruction cache, it needs to load it. And this causes stalling because the frontend isn't allowed to do anything, and now it needs to wait until the memory unit loads the data and whatnot. Usually this is not a problem unless the code is very huge and it jumps around quite a lot. Usually what's more common is the backend stalling, because the backend stalls might happen due to memory pressure, due to very low ratio of memory operations and actual operating on the data. So for example, I load a lot of data, but I operate very small amount of it, so I constantly load and I stall my backend. This is an example of perf output for the sleep command. So the perf output is pretty smart that it doesn't actually report like the whole thing, because the sleep was scheduled to execute for 5 seconds, but actually sleep doesn't do anything. It simply registers an alarm in the operating system, and then it wakes up the process. So the perf actually adjusted for that because counters are global per CPU core. And we can see some statistics, and in this case we can see stalled cycles backend, it's 30%. If it wouldn't be for sleep, it would be something like we process some data and whatnot. This yellowed number would indicate that we have a huge problem, and maybe our data is not stored properly. Maybe we can optimize it. Maybe it's not stored back to back. Maybe it contains a stride, unnecessary stride, and whatnot. We can see that by default it reports like branch misses and whatnot. You can tune it to report as many counters as you want to whatever counters you want, and it's actually like the list of counters is pretty big. Like my 10-year-old MacBook laptop contains, I don't know, like 100 different counters, it seems. So tips would be to minimize data dependencies. Be very predictable and measure. Because without measuring, it's just basically a guesswork. So I would say that measuring needs to be done, and then based on the results, an experimentation needs to take place. Trying different compilers might work, because in some cases I experimented with, GCC produces better results, but in some cases CLang produces better results. Sometimes pointing to the different architecture actually performs even better. And get familiar with target hardware. So this tip is crucial, I think, for high performance. And for example, in this cases, unified architecture sort of wins, like in Apple's case, because you have like one chip to rule them all. So in case you learn everything about this one chip, M1, for example, you might transfer your knowledge to all of the laptops and iPads using M1. And for example, Intel's and AMD cases, your specific knowledge about, for example, Skylake might actually not translate that directly to later revisions of the CPU. And usually you need to skim through tons of documentation from the vendor, and some stuff is not even there. Like, for example, you can't find the latency of instructions anywhere unless you find like some dude's random blog who is obsessed about doing those, and he provides those. Okay, vectorization. So let's consider we actually did everything we could, like our data is perfect and whatnot, everything works. But can we like squeeze some more? And vectorization comes into place. Vectorization in CPU terms is basically operating on things in parallel. So in this example, we can see 2 tuples or 4 floats being added like at once. You might imagine that it happens at once, going down. So brief history, Intel MMX hit in '97, which is basically like once the SMD hit the mainstream. And after that, the SSC, AVX, AVX512, Neon in ARM case came into the market. So auto-vectorization is the compiler's ability to vectorize automatically. You don't need to do anything about it, just write code and it magically happens. It does so by matching code with patterns it has built in. And you can read, for example, CLang and GCC have like these huge pages of patterns they can detect, and then they can properly auto-vectorize. However, it's not always as simple, so the compiler makes the cost analysis. It basically judges how much of juggling with CMD is going to be beneficial. Of course, it's just a guess, and it might be wrong, so sometimes you need to tune the compiler and just tell it, like, do this as I say. And once everything works out, it just produces some auto-vectorized code. How does it work? How does it look like in assembly? And once we see like those YMM, ZMM, XMM registers and instructions starting with V, we can be pretty sure that it's a vectorization in place, and we can see that vMoveApps YMM0 simply moves in something into the YMM register, which is, I think, AVX register. Intrinsics. So coding with assembly is not really like portable and also not the best way to spend time. So compilers allow you to use intrinsics. So instead of saying like, well, use this specific CMD register for AVX2 and whatnot and do this operation, we have intrinsics. So they are just a tiny bit higher level than the assembly instructions themselves. And the compiler then knows how to emit, well, the most optimal opcode for the instruction, because my knowledge might not translate to certain architectures, and you can basically and you can tune compiler to produce code for the target architecture. So using intrinsics is the way. It also handles more stuff for you, like it's a tiny bit portable. It might juggle the registers for you if stuff doesn't fit in the register. So basically, that's the preferred way to go. Some examples of intrinsics. So for example, these are AVX intrinsics, and AVX contains 256-bit registers, which means that it can store, for example, 16 8-bit numbers at once. So we can take like 16 8-bit numbers, like a pair of those, and we can find, for example, an average of each like pair of each tuple. We can find the maximum, the trigonometry functions. We can compare those and whatnot. This is basically what CMD allows us to do. the best docs I found for the intrinsics is Intel Guide, which allows you to select based on the category as CMD version. And what's the best? It actually shows you the pseudocode, what happens behind the scenes. So you don't need to infer by name what actually happens. You can actually see sort of like Pythonic code, what happens behind the scenes. So the reason for compiler not vectorizing the loops is it can prove that the trip count is very, very low. It knows that the loop, the hot path, contains the carry dependency. So for example, we are summing numbers and we have like this sum variable. Actually, it's a dependency. We can't sum at once because we will stall on this one memory location, on this one register. Complex flow, which translates to a lot of code, and basically expensive calls in the hot path. And the opposite tips for vectorizable code. So one additional thing is to always align memory, your data to the memory on the 32 byte bound, because else it's not going to be as performant, and it also might crash. Not the CPU, just the application. Playground time. So I had this difficult problem of summing numbers, and I spent some time and wrote this code, and actually it works. I use CLang, mainly to illustrate the point, because GCC produced better results. And with 320 million random numbers, it averaged of runtime of 82 milliseconds, which I don't know if it's good. It's not bad. Doesn't look bad. So now with our new knowledge, let's split this loop into two different sums, and then compensate at the very end and add those together and see what happens. We benchmark and we get like exactly the same runtime. And this is what I was like, so like, don't I like fully understand this issue? And so I looked into the generated assembly of the first instruction of the first code, because actually this code is the pattern in GCC and CLang. Actually, this is the pattern, exactly the pattern they might match. And this is what the assembly with O3 looks like. And we can see that actually it unrolled the loop, but without even unrolling, it actually used 4 different YMM registers, as we can see, 0 through 3. And at the very end, after the YINE instruction, which simply is the loop control, we can see that actually it just adds all of those intermediate sums to YMM 0. So basically, it did all this stuff for free for us. We didn't need to do like anything at all. It just happened. But now let's go CMD and let's write some CMD code with intrinsics. And basically, the whole magic actually happens at the very top, where we simply have this sumVec, which is just initialized to 0. And when we simply iterate in strides of 8, we load 8 32-bit numbers, and we add those. And in the middle, we can see horizontal sum, because now we have like 8 different intermediate sums, and then we add those together. And this shows 23% decrease in runtime, actually, on this specific architecture. So this CMD code doesn't mean that it's actually the best solution, because compiling and running on a different machine might yield much different numbers. So in general, the basic code is actually much more stable, I would say, and much more predictable. But now let's go to another problem, which is just like counting the occurrences of the needle in the haystack. So basically, we have this result, and we iterate for the whole data set, and then we increment the count. The runtime is 32 milliseconds on average, and now let's go a CMD way. That's totally readable code, which does exactly the same thing. So why it's, I mean, it's not as straightforward, because CMD operates on multiple stuff at once, so we need to sort of work into its way. So at first what we do, we take this needle, which is just a byte, and we simply fill in the whole lane with all of these needles. Then we compare everything, and after comparison, where it's equal, all of the bits are set to 1, where it's not equal, it's just 0. Then we have this magical move mask, which simply takes the highest bits and moves those into the final 16-bit number. And then built-in pop count simply counts how many toggle bits you have. Now, this actually shows 56 decrease in time. This is pretty great, I would say. Not that readable, maybe. But actually, it has cost attached to it. So, for example, now we only have like 1 needle in the haystack. If we would have 2, we can't really use this approach of having a mask. What we would need to do is have like 2 masks, but we have a limited amount of registers. And in case we would call this function multiple times for each needle, actually it needs to go through the whole data set all over and over again. So it depends. It depends on the use case, on the data you're processing and you're expecting. Writing SIMD is not for the general case code, I would say personally. So the conclusion is, the benefits of vectorization is the maximized performance and precise control, and you might exploit the full instruction set, because the new CPU might contain, for example, instructions for certain like crypto stuff and whatnot, and the compilers might need some time to catch up to implement those intrinsics. So basically, by knowing this stuff, you can use all of the latest things immediately. The cons are pretty visible. It's increased complexity, reduced portability, readability, and yes. Thank you. That was it.
Yo, what a talk. Instructions and stuff. Do you have any questions for Lucas, though? Because online people don't have any questions. Boyle, catch it. Left hand, you know? Ooh. Yay, we got it.
Okay, so I imagine, like, correct me if I'm wrong, but there are some like CPUs that wouldn't have AVX extensions on them. What would happen if they would encounter like AVX instruction from your code?
It would emit illegal opcode or instruction. I forgot the exception.
So you would need to have some kind of pre-checks to ensure that you can run these codes.
Yeah, and it's usually pretty common in the code to have, like, if it supports SSC, if it supports AVX, if it supports AVX12, it basically branches. So it has, like, DLLs for specific versions, and load those instead.
So one extra mini question. Would you recommend doing this in production?
I would love...
Okay, any other questions? Yeah, a lot of hands we have. Awesome.
Okay, I saw the comparison with O3 optimization. How would it be with OFast, for example, which has more aggressive vectorization in place?
I tried OFast, but I think that OFast is implied on O3, I think, not?
Well, there are multiple things that are applied there, but I cannot say exact flag that might be given from.
What I gained from experimentation a lot is that actually the results are not that stable, to be honest. And for example, at first I was using GCC, which did just great on my synthetic benchmarks. But once I did something a bit slightly bigger, actually Clang produced better code. So I would say that I don't know about OFast, but I tried like tuning the vectorization width and whatnot parameters to see if I can outsmart the compiler. And in some cases, actually, it's possible. Like once you saw like those 4 intermediate sums, you can actually force the compiler and say, use 8 intermediate sums. And it might yield better results. So it varies.
Yeah. All right. Thank you for the question. Yeah, another one. Carlos, right?
Nice throw.
Hello, hello.
Okay.
So like in recent years, we kind of saw like a jump from x86 to ARM architecture. And it's well known that ARM is kind of like simpler instruction set and it's more parallelized. So what do you think it's gonna happen? Are we gonna continue on this path, like kind of split architectures and like x86 is better for one thing and ARM is better for another, or maybe we're gonna see like a jump where all the CPUs are ARM and all those kind of let's say more parallelized tasks are done on GPU.
Okay.
Because yeah, in recent years also there are a lot of more programs that use GPUs for these fast computings, and actually the program that used like with the bitmask.
So what's the question?
It was like more like a shader code.
I think I got
so
the
yeah,
question.
so I want to like hear your general opinion. What's this
so I found
in?
this pretty funny that x86 is KISC, which is complex instruction set, and then you actually split it into micro-ops, and the backend executes those micro-ops, which sounds very like RISC, which is reduced set, which is what ARM is. So to be honest, I am not sure. It seems like ARM is more like power efficient. Not sure why. Maybe it needs to have like a simpler front end, but I am honestly not sure where it goes. For me, it sounds that ARM approach of RISC is a better one because it's simpler one. I think because you have micro operations, you can combine them more efficiently. But I think x86 isn't going like anywhere anytime soon.
Yeah, thank you guys for the questions. If you gonna have more, please catch Lucas around break. And now we're going to go further, and we're going to go with Benas.
Thank you.
Benas, yeah. Benas is going to talk a little bit about our journey of interlanguages and libraries and how it went at NordVPN. Rock on.
Cool. So hello. As Marius said, I'm Benas. I work in low-level department of NordVPN. And one of the things we do in low-level department is produce cross-platform libraries for NordVPN applications. And usually these libraries are written in different programming languages than the applications themselves. So this is why I'll be presenting a journey through interlanguage communication between libraries and apps in NordVPN. During today's presentation, first I will talk about FFI and what it is. I'll continue with early days and how we used to do it and the problems we faced. After that, I will talk about a tool which helped us solve these problems. And then I will talk about yet another tool which made our lives easier. But before jumping into FFI, I would like to start with the most primitive example of code communication, which is a symbol that is written and used in the same programming language. So in this example, I have a function header which I wrote in C. And if I want to use this in my C application, I could simply import the header, call the function, and print this output. So everything would work. But what if I want to use the same function in different programming language? And in this example, I have Go. So if I do this in the exact same fashion as I did in C, this would not work. So what can I do about this? And the first thing which comes to my mind would be that I can simply rewrite my function to Golang in this example. And this would be perfectly fine in this example. But in real life, we usually have way bigger APIs with lots of functionality. And in case of NordVPN, this would mean that we would need to rewrite the same code at least 4 different times, so that is not scalable. Another thing I could do, I could, for example, create a HTTP server and host my function there and access it from my application. While that also would work, it would add too much of an unnecessary overhead for such a simple thing as calling a function. And the thing which we end up doing the most is called FFI. And FFI stands for Foreign Function Interface. And what it is essentially a mechanism for code which is written in different programming languages to communicate. And while this description includes services as well, the most traditional way of doing FFI and the way which is available in majority of mainstream programming languages is communication with C application binary interfaces. So we usually have multiple pieces of code which is written in different languages, and they're operating within the same application, and they're communicating via C essentially. Okay. So now we know what FFI is, so let's jump back into our example which was not working, and let's fix it. So what I would do in Golang, I would tell my compiler that I'm using C, then I could simply import the header and call the function, and everything would work. So it's pretty simple, right? Where is the problem? And in order to see the problem better, let's take a look at a bit more interesting example. And in this case, I have a function which accepts a string and returns a modified version of that string. And if I were to do this in Golang, it would look something like this. And a bit more stuff is going on, so I will go through it. So here I'm converting my input from GoString to a C string. Then I can actually call the function, and this returns me a pointer to a message. And I can use that. Then I can convert this pointer back to a Golang string, and this is the most important part here. So usually when you see keyword and save, something interesting is going on. And what I'm doing here, I need to free the memory I just used. And if we don't do this, I will have memory leaks. And if we do this incorrectly or do this multiple times for the same pointer, I will have a thing which is called a segmentation fault. And this usually ends up in crashing my application. So usually this is not what we want to have, so we have to do this. And keep in mind that this is a very simple example of a single function with just 2 pointers. In real life, as I said, we have way bigger APIs with lots of functionality. And in case of NordVPN, we would need to write bindings in this manner at least 4 times. But nonetheless, it works. And we can finally print our message. Cool. So now we know what the FFI is and how to use that. So let's jump into early days of how we used to do that. And by early days, I mean the period since we developed our first library as low-level team until July of 2020. And how FFI used to look like back then? Well, it was exactly what I showed you. We were producing libraries, providing header files for the app teams, and usually the app teams were responsible for creating bindings for themselves. And this worked until we started working on the library which is called Lemoose. Yeah. And Lemoose is a privacy-oriented library for app analytics collection. And 2 things are important here. One, that this library is written in Rust. It will be more important a bit later in this presentation. And another thing that is that we decided to go with API generation approach for this library, as we wanted to enforce how the data is being stored and sent from the application. So this means that now we have generated API which can be regenerated at any point of time. So this means that creating bindings manually is simply not a viable option anymore. So we needed to investigate some options to automate this part. And we found a tool which is called Swig, and that stands for Simple Wrapper Interface Generator. And what it yeah, it's very simple. Yeah, and what it is essentially a binding generator for a code written in C or C++ to a variety of high-level different programming languages. And why we decided to use that? Well, it can generate bindings directly from the C header files. And we were already producing those files, so this was very nice for us. Another thing which is good, it can generate bindings for Java, C#, and Golang, so we have the support for all of the target languages we need. And also, it can generate bindings for the primitive types and strings. And strings is very important, as we don't have to handle pointers for strings anymore. And we can do actually a lot of things with just strings. And this is the example of the most primitive Swig template you could have. And we were using something similar in libmoose. So basically, you just specify the header you will be using, and Swig is able to generate bindings out from that. So yeah, let's take a look at the example we had in libmoose. So here we have a structure for event of libmoose called developer logging, and it has 3 fields: optional integer, optional enum, and optional string. And we wanted to generate a function which would be able to send this kind of data. And we are generating function, in this case, it's called sendLog. But with this simple approach, there were some obstacles we had to overcome. And one of them being then is that since we're using C headers directly, C doesn't have a concept of namespaces or packages. And since we're generating the code, it means that the probability of generating functions and with same name and having name collisions is pretty high. So we prefixed all of the functions we generate with libmoose tracker name. Also, Swig doesn't have support for error types. And in libmoose, none of the functions actually needed to return anything. So we were lucky, as we could simply use error codes here. Also, we do not have support for objects in this way of doing bindings with Swig. And luckily, in libmoose, all of the objects we had were actually singletons. So we were able to add even more words to the function name, and that worked. Also, structure support in Swig is pretty complicated. So what we did about this, we flattened all of the structures, and we created a separate parameter for each of the field of the function. Yeah, also, optionals was not an option for us. And for this, we decided to use default values for representing nulls. Another thing we did not have in Swig by default was callbacks, but luckily in libmoose, we did not need them. And yet another thing which was missing was any kind of list or array support. So for this, we worked this around with using comma-separated value strings and parsing them at the other end. So yeah, we did a couple of workarounds here, but nonetheless, we still managed to generate functions. And this is the header of generated function in Golang, so we can properly use that. Cool, so that works. There is a minor issue, though, that even though we are using Rust in the library, we still have to care about all the manual memory management and use C pointers. But this was fine, considering we did not have to do this in the bindings anymore. Yeah, so that's the updated timeline at this point of time. So libmoose kind of started a period when we were generating bindings with Swig. And after that, we were still using Swig, but we did some adjustments. And important library here was libtalo. And libtalo is a main library behind NordVPN, which is responsible for VPN tunnel management. And this library replaced Nordlings Go, and this library is also written in Rust. So we basically copied everything we were doing in libmoose and applied here, but we needed a couple of extra things. And one of those things is object support. Even though libtalo is also usually used as a singleton, we did not want to have lots of static functions with big names. So for this, we needed to add even more pointer handling in the Rust, which is not nice, and also do this in the Swig template. And also, we needed callbacks. Basically, we wanted to notify application that something happened on the VPN tunnel, so application could react to this. And for this, once again, we needed to add pointer handling in Rust, which is usually not what you have to do in Rust. And also, we needed to implement mechanisms for each of those callbacks to all of the target programming languages. So remember this little guy? This is him now. I will not go into details, but what we have here, we have mapping of all of libtalo functions to a talo class methods. And also we have implementation for this event callback in each of the languages. And we also needed structs here. And we needed structs for reporting different kinds of events for the application. And considering how much effort it takes to generate a single callback with this approach, we decided to cut corners here, and we created a single callback which just gives us JSON, and it was up to the application teams to properly parse it. So yeah, we kind of have a bit nicer bindings now, but these bindings are still very far from perfect. And in terms of automation, this is actually a step back to good old times where we were doing manual memory management. But instead of relying on app teams to do that, now we as library developers had to do this. And the maintenance of these bindings was not very nice, and we did not want to do this anymore. So we were investigating a couple of other binding generation options. We were even considering implementing our own solution. But we researched and we found a tool which was very nice for us, and that tool is called UniFFI, or Unify as it's pronounced in the official documentation. And that's basically yet another binding generator maintained by Mozilla, which can generate bindings from Rust to different programming languages. And why was it so attractive for us? So first thing is that it can generate finally all of the types we need. And this is the table from Unify documentation of supported types. So on the left column, you can see UDL type, and UDL stands for Unified Definition Language. And on the right column, there is a representation of each of those types in CFFI. So here we have what is called primitive types. So they're pretty much represented as they are. And here what we have is so-called complex types. So we have all the strings, dictionaries, and sequences here. And all of these are represented as Rust buffer. Rust buffer is essentially a byte array. And this means that every time we are calling a function, we're doing serializing and deserializing of our data on both ends. And we have the last type, which is called interface, and we can use that for our object implementation and callback implementation. So good, we finally have all the types we need. Why else Unify is good? So not only it can generate bindings, so our library users are happy, it also generates scaffolding. And scaffolding is a piece of generated code which converts between those UDL types and CFFI. So we as library developers are very happy about this. And this would be the example for the say hello function I already showed in the UDL template. This would be the implementation of this function in Rust, and this is the header of generated function in Golang. So if you can see, we're using plain strings here. We don't need to care about pointers anymore. And this would be the representation of this code in the C header. So if you can see, the function is properly prefixed, and where we use strings, these are represented as Rust buffers. And another good thing about this, that Unify was ready to be used for Kotlin and Swift, and these are two of the languages we need to support for NordVPN. Yeah, of course, no software is perfect. Unify is not an exception. And the first drawback of Unify is lack of performance, and we get this loss of performance basically due to the fact that we're serializing and deserializing all of the data in each of the API calls. And this interface mechanism, even though it's pretty efficient, it has its own overhead, so it cannot be as efficient as simply using raw function pointer. Also, another kind of drawback is that, well, Unify was designed for Rust, but for us, this was not actually a problem, because at this point, we already migrated all of the libraries to Rust anyways, so it's fine. And also, Unify does not generate bindings for C# and Golang by default, and these are two of the languages we need. But in the last slide, I showed you an example of generated code in Golang, and how I was able to do this. Well, we liked Unify so much that we decided to create our own binding generators, and we contributed to the open source. So if you went to our organization in GitHub, you could go and start our repos. And we see that users are actually using this. By users, I mean not only people from Nord Security, and they're creating issues, and not only that, they are also contributing to our repositories. And this is a screenshot from the biggest contribution we've received so far. We would have done this ourselves, but someone else needed, and they decided to contribute to us for free. So we get all of the benefits from open source. Yeah, and this is the updated timeline. So last summer, libnudler migrated its binding generation to Unify, and that kind of marked the period where we will be using Unify. And we were actually in progress of migrating the rest of the libraries to Unify as well. Okay, let's wrap this up. So I know that working with raw pointers is fun, but sometimes it's really not worth it. I would really recommend you considering binding generation options if you're working with FFI. And if you need that in Rust, I would really recommend Unify. Trust me, it's great. Another advice from me would be a bit general one, but when you're researching tools for solving your problem, and you find very nice tool which doesn't fully support what you need, consider contributing to these projects. Not only you, but community will benefit out of that. Yeah, as I said, FFI is kind of a synonym for C interoperability these days. So if you really want to understand what's going on, there is basically no other way than just learning C. So you use this as an opportunity. I wrote this kind of as a joke, but it's not really a joke. I know that not everyone in our security is using Rust for their library development, and we have some C++ guys. So if you want to have nice bindings for your users and possibly have less headache for yourself, consider implementing scaffolding part for C++. That would be something nice to see. Yeah, and very last thing, I would like to say thanks for a very special engineer who was the main companion during this journey, and that person is Mr. Kristupas Antonavičius. Yeah. Yep. So thank you guys, and I'm waiting for your questions.
Yo. What a journey, Benny. What a journey.
Yeah.
Incredible talk. I have a question before deep diving into the technical ones. What was the most memorable thing for you in this journey?
Most memorable? I would say probably working with libmoose bindings, because this was kind of a first time when we actually tried binding generation approach. And we thought that we improved the lives for our users. Well, I don't know if we did, hopefully. So I would say this was the moment.
Okay. Any other questions from the audience? Okay. Let's try with a comment. Okay, come a little bit closer, because I'm gonna throw it again. Okay. Woohoo!
Yep. So as you saw, Benas actually did a very good, let's say, timeline of our libraries. Now we can even go back to it a little bit. So actually, libtallo hasn't changed its interface almost since V0, and Swig is probably the reason for it.
Yeah.
Okay. Any other questions? Yeah.
Is it complex to call Go functions from C code the other way around?
No, it's not, but you have to expose your functions in the way which would be represented one-on-one in CFFI. If you do that, you can easily call it.
So Go has some dedicated tools for that?
Yeah.
Okay.
Oh, sorry.
Okay. Any other questions from the audience? Looks like not. So let's jump forward. Thank you, Benny. And this time we're going to talk a little bit about LLMs and what the hell is Hippocampus. So Paulus is on stage, and take it away.
Yeah, hello. So welcome to my presentation. And to start off, I want to ask a few questions to the audience. So please raise your hand if you would answer yes. So how many of you use large language models like ChatGPT daily? Okay, something that I would be expecting. How many of you try to delve deeper inside and try to understand what's happening under the hood? Okay, and how many of you found some hard limitations or problems with current models? Okay, so that's so I hope that this presentation is gonna be useful to most of you, and that seems to will be the case. And to begin, I would like to ask a question, and personally, this is a question mostly to me. What is the biggest limitation of LLMs? There's multiple of them. There is hallucination. They have no ability to properly learn new facts. But when I started using large language models, one of the biggest problems I found instantly was the context size limit. Basically, when I would be chatting with ChatGPT for an extended period of time, or I would try to upload a huge document and ask some questions about it, I would often run out into a case where the API would simply error out, and if you use OpenAI's API, you would just get an error saying that a token size limit was reached. And I really wanted to understand why this happens. And to do that, let's try to dive deeper and understand what's going on there. To do that, we need a subject. And luckily for us, there's a lot of open models that we can actually take and run locally. We don't need expensive hardware to use them because there's like a lot of quantization techniques that allow you to run them locally. And you're also not like blocked by OpenAI and their API telling you what to do. So specifically, I will be focusing on Llama 2, open model made by Facebook. And just like most other large language models, it is a transformer, and specifically a decoder-only transformer. And most of the areas I'm going to cover are important to all of transformers, but it has some specifics and corner cases which are specific to Llama. So the parts I'm going to cover are not the extended list. There's way too much to cover in a simple 20-minute presentation. But fundamentally, there's like 5 parts that I'm be focusing on. There's tokenization, embedding, positioning, attention, and decoding. So the easiest way to understand the problem, at least for me, is to take some kind of practical example. So let's say I have a sentence, the best VPN in the world is. And I want to see what happens in the model, what actually goes on in that head. And first thing we would see that actually it is converted to the list of integers. And you might look at it and it looks a bit weird, like it doesn't match words exactly. It isn't like individual characters. So what's going on? And what would we see that most of the language models have something called like their inner vocabulary. It's not a word vocabulary per se, but it's like a different byte sequence vocabulary. And specifically, Llama uses a 32,000 word or token specifically vocabulary. And what it does, it tries to match the largest sequence in the given sentence, or sometimes the best match, and just chops the sentence and gives you the index to that vocabulary. And in this case, it was chopped into the best VPN and like the world is. And you can see it has like spaces, and like these sequences are kind of arbitrary. And the interesting part is that it's still just numbers for the models. It doesn't really mean anything to it. So it somehow has to extract and also abstract some areas of those tokens. And to do that, the models employ something called word embedding. So your given sequence just gets turned into another array of like arrays. And specifically, it's an array of 4,096 floats. And you can kind of imagine those arrays as like multidimensional vectors. And I'm going to use this analogy a lot in this presentation. But you can basically imagine that every word points to some kind of meaning space in a multidimensional space. And the words which are closely related point to a very similar direction. So taking a very simple example, we could imagine that we have 2 independent variables, catness and dogness. And the model, through the magic of backpropagation, learns how to like place those different words in this plane and in this like 2D dimension. And if a model is good, you would get like cats in the cat space. You get Sphinx probably a bit closer to the dogness, Akita somewhere in between, Wolf way to the dogness side. And if a model is good, horse wouldn't get like zeros from all of those directions because like it's neither a cat nor a dog. So then those word embeddings get fed into the most probably important part of any transformer, and that is the masked like attention layer. In decoder-only networks, it's like masked attention, which doesn't allow the lookup back to the lookup to the future. But you can kind of imagine that this attention works in such a way that for each token we get, we generate 3 new vectors. They are of same 4096 length, and we have like different purposes. The value vector is the V is kind of probably the easiest to understand. And for each individual words, it encodes some kind of understanding what we are talking about. So maybe when we see best, we can have some kind of list of the best things we know. If we have world, maybe we're gonna have more information about countries, areas, bigness, or something in that area. The queries are keys are a bit more interesting, and they're even a bit more interesting than a typical transformer, because in Llama, we specifically are a bit modified using something called rotational positioning, which allows you to encode the relative position of the words or the tokens. And why that is necessary is because like two sentences like I eat pizza and pizza eats me are like two words entirely. And the word query and vector embeddings by themselves always produce the same result. So you need to shift them a tiny bit to encode the positional information. Then we go back to using those modified queries and keys. We go back into the attention mechanism. And you can, when we are doing inference, you can imagine that we generate query just for the last token. And we get a key vector for all the previous words we received. And just like previously, the word embeddings who would point to the similar direction are similar, here the vectors which point to a similar direction tell you which are more important to this specifically is. And here you could kind of estimate that best and V and Pn is like the important tokens in the scenario, and we could just imagine that this is points back to those areas. What happens next is that we can use this fact that this underneath everything is just vectors and do scalar multiplication to receive this kind of a scalar value indicating how important it is. It actually runs through something called softmax to normalize it between 0 and 1. And then we multiply those scalar values by the vectors we have for each individual token. We do an addition on them, and we add extra nonlinearities, like typically here there are activation functions, and we finally receive the final vector, which points into what we are actually thinking and want to say next. And this final value vector is finally decoded into a prediction list. And when I was running it through Llama, it was typically trying to say to me that it depends, and that's why we would see maybe the first like A and matter, and like you could see some inklings of Nord or Express somewhere in that list. So from the model itself, it doesn't seem that, at least in inference time, there should be any limits. Like you can give an arbitrary sequence, we all get turned into the same vectors, and you could theoretically give like a large sequences of numbers. And in Llama case, there's like you could actually give bigger sequences, and the model would try to process it. The problem lies that the model is not actually trained on those larger sequences, because when you're training, you need to keep this kind of matrix, which grows quadratically, because for n input, you need actually n by n matrix to keep all the gradients, predicted values, and be able to nudge it and do back propagation on it. So the fundamental reason practically lies in the training itself. So since we have this limited model, which has limited context size, I personally like to think how human brain handles like large contexts of information, and specifically how our working memory works and helps us in this situation. Why I want to look into human brains, because like there is like some estimation how much power does the human brain use, and it's like somewhere around 12 watts, and how much wattage does the OpenAI's RAGs use, and it's somewhere around 3,000 watts. So there is like a good argument that brains are more efficient than like your typical large language model, and we're probably doing some like interesting algorithms there to improve that. To understand and draw some analogies, which is going to be like gross oversimplification, we first have to look into the most kind of busy part of the brain, and that is like the entire cerebral cortex, where your brain matter and like 80% of synaptic connection exists. And then we're thinking specifically about working memory. Most MRI-like research and functional magnetic resonance typically point that your working memory exists in your prefrontal cortex. And you can kind of typically see that the rest of the cortex is useless, like distributed database, keeping your long-term memories, your thoughts, mechanisms, and so on. And the question is, how does the brain actually try to process this information? How does it take memories from the long-term part and fetch it into working memory when we need it? And probably not surprisingly enough, there is this very interesting structure in the brain called hippocampus, which actually has two different states of operation, one for awake brain and one for the sleeping brain. But I'm going to focus more on the awake state. And what you can imagine, when the working memory like thinks it does its stuff, it from time to time sends messages to the hippocampus, which then like indexes information in the rest of the cortex and brings it back to the your prefrontal cortex. And you can kind of imagine this as like an indexing service for your brain, which allows you to get the relevant information. And of course, hippocampus is way more complicated than I'm covering here. It is also responsible for episodic memories and like in general learning. But we can kind of squint our eyes and simplify this and make it kind of useful for LLMs. We can imagine that we have prefrontal cortex, the working memory, and that would be like the green part, our context for the entire model. It has all the tokens you take in and what you're trying to predict. Then we have the red part, the rest of the cortex, and it would be like our huge database of things we encountered, things we remember, and things we want to take in depending on the context. And finally, we would need some kind of indexing service, the hippocampus, the artificial hippocampus, to actually do this retrieving. And what people have discovered, that you can simply use that inner embedding, the one which I told you that it predicts like the next token of sequences, as a vector to actually index any information you take in. So you can imagine you are going through the text, you have like a new memory, you decide to index it, you get the embedding, store it in the index, and then keep it for the retrieval when you encounter something similar. So yeah. And this is like at the core of what I'm using for my project that I'm working on a personal time. I call it for now like Entangled. There was like a different name, but I want to build my personal knowledge system and like AI to help me like understand larger scopes. It's currently still in the works, but I hope that in a few months I'm able to give you an access to a closed beta at least. And until now, there's like a lot of existing solutions. If you're a rapid Obsidian user, there is like a very nice plugin called Obsidian Olama, which allows you to run like local models and then just interact with the APIs and extend your knowledge database with this kind of inference and more knowledge. Then there is a more corporate solution, Nuclea and NucleaDB, but then you would have to trust that their API doesn't really like take in and use your data inappropriately. And there is like more experimental ones like HTO GPT and Second Brain, which also try to do something in the similar area and use similar mechanisms to work with. So thank you, and I hope that this presentation, like it covers very little, and it is a way bigger field. So, any questions?
So, any questions from the audience? Oh, we have one. Okay, let's try.
Thank you for presentation. You showed the slide where you basically multiply each word by the importance of it.
Yes.
Where do these numbers come from?
So these are actually learned, and you have multiple heads actually. It's like I showed just the one like cell, but it's multi-heads, and all of them learn like different areas to look at. So maybe one would look at the contextual information, another would look at the grammatical representation, but it's really a black box where it's like going gradients. And I personally wanted to like deep dive and maybe like look what each like area would get and what kind of values would see, but I didn't have that much time.
Thank you.
Okay. Yes, Luki. The cube is flying around the audience.
Hey, thanks for a great presentation. I have a question related to hallucinations.
Yep.
So basically, as I understand, hallucinations is like LLM doesn't actually know that it's hallucinating. It's just following some sort of stream. But are there like any ways to actually like for LLM to detect hallucinations somehow?
I don't know any like specifics, but typically that if we provide some context to it, it allows the model to be a bit more grounded and like there's gonna be less hallucination. But like one fundamental issue is that like the model doesn't actually choose the word, it just gives you the prediction of the next word, and you're always rolling the dice. So unless like you train it, maybe use some kind of better like selection algorithm or like better ways to select those words, I think like there's gonna be some randomness which allows the model to go into like weird areas. You probably could have extra like critic network or something that would probably analyze and say, oh, you're talking bullshit, but it's becoming a multi-agent setup, which I'm not sure that we would have enough compute for that.
Okay. Any other questions, guys? Yes, we have two. Awesome.
Nice. Thank you for the great presentation. I have a question. Do you think ChatGPT is getting less smart?
So there's a lot of buzz about that yeah, it's getting less smart, but I'm guessing it's interacting with more people. So would you get more smarter or less smarter interacting with all of the people? But yeah.
Yeah, that's a good one.
That's a bold statement, Pauli.
Well, it depends, but yeah.
Yeah, Rytis.
Yeah, so I'm kind of thinking, do you think that the current versions of the LLM models, which are running locally on users like laptops, let's say, or similar, not very powerful machines, are good enough to be a product in itself?
So that's what I hope on, at least. And I really find MeshNet intriguing for that case because like then I can distribute it through multiple of my computers and like be not worried that I can deliver data like unsecurely.
Yeah, that's exactly my thought.
Yeah.
Okay, the last one, guys.
On which layer do you adjust the ethical behavior of the LLMs?
So on all, like it's not like the layers, but on all of them, because you would need to find specific back acting like layers for it. So it's the model doesn't really have specific areas which are acting badly. It's like distributed through the entire network, and that's why you do like reinforcement learning just to try to force him to act goodly or like not badly.
All right.
Okay, I think that's a wrap up for this section that we had in the morning. We're gonna go for lunch right now, and we're gonna see in 1 hour or so. So let's meet again here at 1 p.m. And I am encouraging people again to meet us live here at Building B. If you are in Cyber City, please come. Let's enjoy the Tech Days together. Hello and welcome back to the Tech Days, the second section of today. And first we're gonna have a presentation about full stack text automation by Nikolai. So Nikolai, please welcome to the stage.
Hello, so let's start with the big question. How was your lunch? So, okay, so I see some good lunches, right? Let's do voting. Okay, now then I have two tasks today. First is to present this presentation, and the second one is to make you awake through this whole presentation. So I do have some tricks, but hopefully I won't need to use them. Now, before starting the presentation, I want to get the expectations right. So this is not going to be a guide, step-by-step guide to create full stack test automation in your project. This is going to be about idea, perspective, or also hints, what you can use. And hopefully this will be an inception. So the next time you're going to be thinking about test automation, you're going to start asking good questions. So, but before we start, we need to start from the beginning, from the very beginning, the Big Bang. And when the universe was 0.00001 second old, it was a hot mess. But in that hot mess, something magical started happening. Good practices starting forming, like Dry, Solid, Cupid, Naval Film Filter app. But most importantly, test automation pyramid. For many decades, smart engineers tried to figure out how to use this automation pyramid into the automation strategy. But unfortunately, all of them failed. We can take a look at this test automation pyramid. So you have two key points of information. One of them is that there's more than one layer of automation there. And the second one is that the ratios between those layers are in a specific shape. So you should have less UI tests than you have unit tests. Well, maybe we can use that information to design our test automation strategy. For example, for every UI test, we need to write 2 service tests and 3 unit tests. No, it doesn't make sense. It has nothing to do with the quality, just quantity, but it's not the most important part. Now, the other thing, and other idea how we can use this was proposed by Noah Sussman. So he basically suggested us to reimagine this test automation pyramid as a bug filter. So basically, you flip the pyramid upside down, and you still have the same thing. Like unit test is the biggest part, and now you can imagine that the build is going through our filtering system, and we clean it out of all the bugs there are. So I think we can make a strategy out of it. So let's try to do this. So bug filter, the first layer is unit testing. So you can do a lot of things with unit testing. You can do a lot of quick and fast and tests where you don't even need to deploy your application anywhere. But unit tests have their own limitation. They can't test all of the things. That's why you need to do extra layers of testing. So this is where API, contract, or service tests are coming in. So, but in order to write them, you shouldn't duplicate whatever was covered with unit test. You need to expand it. So you know that there is a limitation of unit testing. It can't cover everything. So you just add those tests which you can't do with unit test in API and contract testing. So they're not the same size and even bigger because they can cover more. Only the things that you need, what you can't cover with unit test. Same goes for UI testing. You only add whatever you can't test with UI or like unit or service test. Now, we can use this as a strategy. So let's imagine we have a build riddled with parasites, with bugs, and it's waiting for us to use this filtering system. So we have a first gate of defense, unit testing, and it kind of reminds me of tower defense. You have some bugs, they try to get to your production, and you have defense system in order to rid them of that. And let's have our first wave. So first wave is there, and we run our unit test on this build. So what we have is that what we expected, they can't find all of the issues. The unit tests have their own limitation. So you find whatever you can find with unit test, then there are some left, then you run the rest of those layers of automation in order to catch all of them. So API testing can help you with some of them, but not everything, and then you finish up with UI testing. So this is the strategy, how you can use your test automation as a filter for your builds. Now, there are probably going to be some escape defects. You can't avoid that. It's inevitable. But we're going to come back to this topic a little bit later. But now let's concentrate on this specific UI test. You probably can't see it, but that specific UI test. So let's say that test is there to test our logic for discounts. So we have our basket for our items we want to buy, and every third item gets some kind of discount. So this is the logic we want to test. And we know that there is a bug in this logic, that bug, which is caught by unit tests. So what happens with our UI test? Do you have any ideas? What's the value of the UI test which is searching for a bug which was found in unit test? Yes? You don't test, well, CSS, I think not that much you test with visual regression maybe, but this is also a specific test what you can't find, but we're testing the logic. Even if a bug is there, your visual regression test wouldn't find it. Yes? It's not that, it wouldn't happen. You can also find it with maybe API testing as well. You don't need to write your UI expensive test. So what I wanted to get to that answer is that it's going to be useless because the bug you're trying to find in the UI test is already found in unit test. And why it is useless? Because this is our setup for pipelines. We run unit test first. If there is a bug, if there is a failure, we need to fix it before we can move on later. So that bug have to be fixed before it even reaches UI testing. And then you fix it, you run, it's passing, and then it's going to another stages. So this is the reason why that UI test will probably gonna be passing all the time, and it will not give us any kind of value, because we already find it. And this is the issue of duplicate testing, because we don't care what we did before if we write UI testing. We don't know what we did with unit testing and API testing, and we duplicate the effort. And this is might be the reason why our UI test doesn't catch a lot of issues, because we already catch them in previous layers. So this, in best case scenario, that test, UI test, is going to be always passing. So we only wasted our time implementing it. But if it's going to be flaky, if it requires maintenance, if it requires you to, every time you change UI, you need to fix that bug. So it's a lot of effort. It's not only initial investment, but also upkeep and maintenance for that UI automation as well. So every time when we make this kind of mistake and we duplicate it, we have a long time to pay that price. It's not only one-time effort. So, so this is the reason why we should avoid duplicate testing, and we can make some kind of a survey here right now. So how much of your project do you think have duplicate testing? Just make a wild guess. Yes? 70% is duplicate. Okay. Can you imagine 70% of something that you shouldn't even be writing? So out of all automation or investment you did, 70% might be not even useful at all. So this is a big problem. We need to solve it, and there's no tools or guides or metrics where we can use to help this one. We need to use smarter ways how we design automation and make a strategy affect and reflect that in order to get there. So it's a big problem, and I think it's an industry kind of problem, and we need to be aware of that and try to figure out how we can solve it. But now let's jump to those 2 escape defects. So should we catch them all? Is that the goal of our automation? Should we find all of them and invest and try to have 100% coverage, not only from code perspective, but from everything, from all the test cases? Is it our goal? No. Probably it's because it's too expensive. If you're going to cover everything, it will be very, very, very expensive. For example, if you support latest version and 2 previous versions of Android, iOS, Chrome, whatever, you need to test them as well. You need to run your automation to make sure that those versions you support officially, it doesn't have a bug. Do we do that? Probably not. So we have this understanding that there's some point in this investment in automation and value you get from it. There is some point, breaking point, where you say, this is enough, this doesn't pay off. So where is that point supposed to be? Where do we need to make this gap and say, this is enough? It very much depends on the industry you're working. If you're working in medical life support system, probably you're going to get very, very far, and you probably invest even more, whatever you can, just to find even get less risks in your system. But if your system can tolerate risks, maybe you can do Pareto principle. Maybe you can do 20% of investment and get the coverage, good coverage, and maybe that's enough if you can react to those bugs in the production and you can fix them fast enough. So You probably seen the presentation like half a year ago in previous tech days about risk-based testing by Algorithms. So if you're going to use this approach, if you find out what are the risks that will affect our system, our business, and we should not allow this risk to happen, maybe those are the test cases you want to cover. Maybe usual use cases, how the users are using the system. Maybe the main criteria, the main things that how we use the system is enough for us to cover, and then we know that 80% of users can use our system. And the rest of them, we can take a risk and just be able to fix them quick enough so it wouldn't affect a lot of users. So maybe that could be a good strategy. So I would invest that 80% I just saved on automation and making 100% coverage into other areas, like ability to deploy quick enough and to have zero downtime in the production, so I can fix everything what's not working quickly enough. Maybe observability as well. I want to know those issues before users start reporting them. I will save some time when I can fix them before it will impact or affect a lot of users. So these are the things that I would rather invest. I would take some risk, and this would be my automation or quality gate strategy. That would be maybe even more cost effective. So I need to weigh risk and cost, how much if I invest into this one. So, but the inner tester in me wants to have 100%. It's just how I operate. I want to have this confidence that I run the test, I get the feedback, and that's it. I can go home and can have a good weekend. But I know that the price for it is huge, and someone has to pay for it. And maybe we divert that price, that budget to automation, but we can spend them on maybe fixing bug, technical debt, or maybe investing into tooling or something that will help us drive further and do more things and better, rather than just investing into automation just to make sure that everything is working. So I can share the example how I used in this full stack test automation in one of the projects. It wasn't NordSec, it was a different company, and we had to migrate from AngularJS to Angular. We didn't have the new test cases, requirements, nothing that was missing, so we had to reverse engineer the requirements out of nothing. So we investigated all the pages there are, tried to find out what is the logic, what are the behavior, what are functions the user can use, then look at the backend as well to find all the edge cases or boundary values. We designed the test cases where we had to make sure that these are still working. We cross-checked them, what layer can we test them? So some of them could be tested in unit test, so some of them in integration test, some of them, okay, this is too big, we can split it. This part can be a unit test, this part can be integration test or UI test. And we did it for all the functionality we found out in the pages. Then we looked at what are the unit tests and integration tests already implemented. And there was really not a good quality. It was basically testing implementation, not the actual functionality of applications. So we had to rewrite them and just to make sure that they are working and testing functionality, not how the code is working. Functionality is more important than that. So we also cross-checked whatever we have implemented, and with the checklist we already have, and we added missing ones. So we added the missing unit test, integration test, and some of the UI tests, because after splitting all the responsibilities where we can test them, the UI test didn't have a lot of left. So we wrote automation. I think for each page we only did like 1 or maybe 2 UI tests, and it was quite simple. You just navigate to the page and you check if it's loading, if a user data is there, and that's it. All of the logic, all of the functionalities can be tested with unit of front end and back end or integration tests. So now we can go to quick summary and just summarize everything that we learned. I would like to use the same tower defense theme we just started. So we have a specific defense system, right? And we have some bugs which we can find. So we have unit test, we have integration test, and also the system test. Now, one of the strategies is that we use system tests because they can find all the bugs, right? It kind of makes sense. We don't need to write any unit test. We write just system test and cover everything. But this is very expensive and time-consuming, and those defenses are kind of slow because it's the last step. You need to deploy, you need to have all the integration in order to test them. The feedback cycle is long. And usually, if you invest into this strategy just to have a system test, you will probably never catch up with the automation, with whatever features you're developing. You will always be behind. The scope will grow, the maintenance cost will grow with it, and you will be behind. So there are many strategies you can choose for test automation which will fail. And there's only a handful which will succeed, which will be in the budget and on time and still efficient enough to be fast and nimble and cover everything that you're developing right now. So those strategies are hard to find, but it's an interesting problem solving and human kind of problem where you can need to use your brains, you can't use tools for it, and it will help you get there. So, because if we will fail the strategy, the bugs will win, they will destroy our gates, they will reach production and affect our users. And we should avoid that. So, I know we can make it, I know you're capable of doing that. If you have a cross-functional team, you have all the competency and the domain knowledge to do this one. So only question is, will you accept the challenge? Thank you. So I have some few more slides, like a few more minutes. After all the questions, we can then look at them. So let's reserve 2 minutes.
Yes, I have the mic. I have one question from Slack. Mateusz is asking, how API tests duplicate unit tests when unit tests single class, function, or method, and API test is testing whole communication between classes and objects? When we consider those tests duplicate each other?
So if you have a logic, a specific case that you need to have, for example, a specific privilege in order to get, or like your level of user should be super in order to get some kind of discount. So this specific logic can be tested in unit tests. You don't need to try API testing when you have a whole system and database in order to test this logic. It's kind of simple. So you need still to test if the whole integration of all these classes and units are working together and you get an answer, but you don't need to attack it with multiple options. Now I have this, now I have that, in order to test all the cases, because you can do that in unit testing. So you just basically do one API testing, make sure that you get the payload, it's correct, it's fitting the requirements, and you get what you expect. And maybe that's it. All the smallest logics, what you do, all these variation mutations can be tested in other layers. Because API testing also sometimes requires you to have a system running, or they are much slower than unit tests. So whatever you can do to test the logic in unit tests is more cheaper and faster, and you get the feedback faster.
Okay, thank you. Any questions from the audience, maybe? Yeah.
So, hi. I see, and I want you to comment on two things. First of all, it looked like your testing strategy is to squeeze out bugs. So it looked like a regression or defensive testing. What is about test-driven development? What's your take? And the other part, you said, can you get bug-free code? And at least the talk I heard is about contract-based, and there are provers. Do you think any of them should be approaching? So unit tests should use provers, one part. And what about test-driven development as a strategy of squeezing bugs?
Yeah, so with thank you for a very good question. So test-driven development is a good thing. But I got the feedback from one of the developers I'm working with. So they said that it's a good thing when you have frozen requirements. So if you have everything frozen, you know what you're building, you can use test-driven development. That's fine. But whenever you change some kind of pieces, logic, whatever you developed, it's no longer this lean and perfect. It's already some kind of modified, and you don't know what kind of expected behavior of a system is. So if everything is frozen, you can use test-driven development with the perfect results that you only write wherever you need, and just make sure that you have a test for every logic you want to implement. But it doesn't work in conditions when you are working in Agile and requirements changes, bugs appear, some kind of issues happen, and then you need to change the code and mutate it, and then it's just losing the value of it. But I would say that one of the things that we can definitely use from TDD is that before starting implementing code, just write the name of the testing you want to perform. For example, I'm trying to write discount. So I'm writing in my name of my, like in this describe statement, like it should check that every third item is to have 20% discount. So I wrote this one. I didn't write the body. It was going to be just a stub. But whenever I wrote the code, I know that this is the function I was aiming for. And I can use this to develop my test cases from requirements, not from the code. Because with the code, there is a very big issue that if you have a code, which is compiling, it's running, it's working. You have 100% coverage, and 100% of tests are passing. But the application might not even be meeting any requirements. Because you looked at the code and you write the test for your code. So you're testing your implementation, not the behavior of what's expected for that application. So it's a very big risk of that the coverage doesn't tell us a lot of information. It's just like, well, it's a statistic from code, but what about the functions? So yeah, thanks for the question.
Okay, we have one more question, maybe? No, just maybe we can roll.
Yeah, and then I can share some more slides. So it might not be a surprise to you that I used DALL-E to generate those images for representation. And I also asked it to generate me test automation permit. And the results were interesting. And so the premises are that the pictures I'm going to be showing now, they are from the same prompt. So generate test automation permit. That's it. That's the simple one. So the first thing I noticed that there was a lot of typos, or like UI to I test. Well, it sounds nice, but what is it? And the other thing that I noticed that usually it generated UI test at the bottom, the biggest part. And I thought that maybe it's a flux. I checked the prompt I'm asking, and almost in all the cases, it was generating those end-to-end tests at the bottom. So I'm not sure if it's a data problem, if it's or it's maybe bad training data or something, but it's a big issue, I think, in the industry. Maybe just reflecting whatever we have right now in the industry. This one I really love. Those very nice logo. So, but when I started to generate even more, there was even more weirder things happening. Like this one had the checkbox. Okay, maybe it's a checklist, maybe it's verification testing. I don't know. And then it got even weirder. Like this is a huge pyramid of this test, GGS, UI, like just random stuff. And here it just gave up. Like I don't know ways I can put tests in random order. This one, like, what's that? Is it a binary code? It's like. Maybe it's a test data. I don't know. So this one is just a bunch of pictures. All the tests are squeezed into one layer. Okay, that's weird. This one, like, it's a weird face there. Like, I don't know what kind of testing it represents. Maybe visual regression testing. So I don't know. And this one is like the world, lightning, like religious stuff, or Illuminati. So, but in defense of AI, well, it's still a pyramid technically, so you can use it as data. So yeah, that's it. Thank you once again.
Yeah, thank you, Nikolai, for a great presentation. I think we learned something that DALL-E cannot generate proper pyramids, that's for sure. And speaking about AI, last week I was in one of the conferences in Geneva, and AI, the word was used at least 10 times in any speech. And on the second day, it was used at least 50 times in any speech. So we have to speak about AI. And for that, we have Ignas. He's going to talk about AI ethics.
Hello, everyone. So Nikolai made a very good intro and showed some pictures, which we will be touching potentially as well. So just to set the expectations, my presentation is not going to be so deeply technical, and I'll try to get those great lunch you had that are sinking in, to get moving and think a bit wider. So AI ethics and why to care. And as Marius just mentioned, AI is mentioned everywhere. Looking into some figures, roughly around 34% around the globe of companies says that they already adopted AI, deployed in one or another way. And around 42% are exploring and thinking about that. And there are a couple of countries that I would like you to, look a bit deeper and where the columns are really high. China, India. Just think how many people live in those countries. And if you multiply that with additional tools like AI, what's the potential is there. If we look deeper into industries, and this slide is from 3 years old, from MIT, some research, but even 3 years ago, at least one process in each industry was using AI for more than 40% of the cases. You look into manufacturing, quality control, testing, and all the related things. Finance, fraud detection. IT and telco, cybersecurity, very relevant for this audience. And if we would get updated data, I'm pretty sure the numbers would be even higher. So it's everywhere, and everyone is using today. Why we should think about AI and it's as a top priority? Because it has a big potential for brand reputation, good or bad. You know, you can use AI to improve your brand reputation very quickly. At the same time, as we'll see later, it can cause you some harm. All the regulations and legislations and all the paperwork, it's catching up and it's coming. As winter is coming, that's coming too. All the complexity and the things what are happening. So in many cases, it's still a black box. We know something, some people know more, some people know less. But there are a lot of unknowns which we cannot control, which we cannot understand. And the last thing is, of course, all the social aspects and the social justice and other related things to us as a society. Lately, we've seen this week big drama on OpenAI. The slides were already prepared, so I wasn't able to add that. But if you follow it, you can see how many speculations are happening out of that, who said what, why, and so, and it's making all this shield and all the mystery around it. So, why companies and everyone should take this into account and should think about it, and why I believe it's a really important topic, and why I believe you should, being, you know, technical community, educating and sharing others in your circles. Because European Union is very intensively working on regulation for AI. I made the slide specifically busy just to show how many things are happening in different countries across the globe. Some of those countries are a bit more ahead, others are taking different approaches, but everyone is thinking about that, everyone is doing something into that direction. What does it mean, this regulation, which will come? Just the question is when. If you know GDPR, and you should know about that pretty well now, very, very similar approach is coming for AI regulations. Up to 6, your yearly annual revenue can be a fine if you will use AI improperly. As one of the examples marked on the bottom, and the reasons why transparency and discoverability is important, was shown that bias was detected through the openly available data for one of AI models, which was used in Medicare. And it was assumed that the model is perfectly well functioning, while independent people checking the data, training data, found out that it was really biased on some specific cases, which could cause someone bad situation at the end. AI game around the globe. We just talked about the Europe. We took quite conservative way. We care as Europeans about people, about our citizens, about our rights, about our data, about the right being able to be forgotten, etc., etc. If we look China, AI adoption is huge. They publicly say we monitor you, we rate you, you caught, you know, when driving and being drunk, you will not get the loan, etc. And 78% of Chinese citizens say we're fine. AI helps us to be a better society. India, similar but a bit different approach, huge potential, a huge amount of people using the same tools. And then US, somewhere in between. They say we don't track you, but then you see a lot of conspiracy theories and other assumptions that you actually being tracked or so. Some regulations are being applied, but then the businesses are worried and say, no, we don't need those. How it looks more from academia point of view. This is very easy to understand picture, diagram, how AI principles are being discussed and discovered by different communities. So just to really do not deep dive into it, a few points. As a Harvard view on AI principles, each AI solution needs to take into account human control and human rights and values. It needs to take into account transparency and explainability, so we should be able to understand why things are happening. Privacy, safety, and security. So these are the key principles that adds up, and there are academia having one point of view, businesses having different point of view, government third point of view, and then you get this very easy to understand thing. But is it really getting more attention? Yes. One of the most popular AI conference sees that the submissions on papers about fairness and bias has doubled in the last year. So there is a big interest and big number of people, of scientists, of our colleagues are taking that seriously. Because in reality, creators really do not care about the users. I borrowed this slide from my former colleague Elius, and it just explains so well this topic and how in reality many things happens, and even maybe sometimes we treat this way our users. So keep that in mind because you're a user every day as well. But getting more serious, what potential causes could be for, let's say, business in this case? How AI can harm us? It just will help us to automate unit tests or anything else, to write the code faster with Copilot or do other great things. But if you look from the company's perspective, Dieselgate costed 30 billion euro to Volkswagen. Cambridge Analytica, more than 100 billion US dollars to Facebook. It was a dip in their valuation, and it took a while for them to recover from that. Apple had a great story about how their Apple Card, if you are a man, you potentially will get a higher rating than if you are a woman. Is it fair? No. Why so? Because there were maybe some mistakes somewhere made or some other things that were not thought very well. So, and this is around us. This is something we should keep in mind and we shouldn't forget while doing the great stuff. And when I mentioned before, here we have a huge technical audience, people really deep diving into very serious technical things. And if we look around us, I just took a couple of current news things, what's happening and how the tools, modern tools can be used and are used for questionable scenarios and questionable outcomes. So this picture was shared in internet for hundreds of thousands times. Even some government organizations shared, very well-known news platforms did that, and it turns out it's one of those that Nikolai generated pyramid of the testing. Someone generated sad and touchy picture about the Gaza and Israel conflict. And yeah, you can see how inaccurate it is. Like in Nikolai's example, it was some text. So you can see some, not fully generated food or something. So it's fake. And many organizations, many news companies that share that, they thought, so what should I do now with this? I got a lot of attention. I gained some money from all the advertisement, but it's not real. We played human emotions. Another one. Adobe is selling generated images. Again, as Nikolai generated pyramid, Adobe generated some war pictures which are nothing to do with reality, and they are selling those on the market. You can say it is an art. It's you know, like taking photos or video footage, but is it real? Does it, you know, really transfer the real message you want to transfer? Big question mark. Disclaimer: this is a joke. This is a satire. Don't take it seriously. Do not relate to any of the potential positions around the world about the worldviews. But this is just to illustrate how easily and cheaply, using modern tools, you can do very doubtful things. And you know, if I would show this to my mother or my friend lawyer, I doubt they would even have a suspicion that this is not real.
War is always bad, specifically for the planet. If we want to continue fighting battles like environmentally conscious humans, we must make the change to sustainable tanks and weaponry. There are so many new concepts for battery-powered fighter jets that can carry many more missiles, biodegradable missiles, of course. Something literally everybody can do to stop this nonsense is, for example, block the roads to gardens and farms so the plants don't get overrun by these heavy, heavy tanks. Hand grenades, very important. If you use hand grenades, please use vegan grenades. No animal should have to give their life for all this mayhem and chaos. They have a special sticker on them. You really can't miss them in the grenade market or wherever you buy them. Yeah, I cover all of this and more in my newest book, Vegan Wars.
So, how much does it cost to generate this video? I don't think a lot. Everyone can afford in this audience or even make the one by themselves. But then the other question is, how much does it cost to detect it and what potential impact it can have? So this one was funny one, nice one, but you know, when I was choosing what to show, you have a bunch of those that would be really, really even inappropriate to show in this audience or would mean big impact. So what do we do about that? What's happening around us? For example, there is one interesting site which is kind of a self-control mechanism where you can submit all the fakes, all the doubtful things you see on the internet, most of them related to AI. And there is a bunch of fact-checking ongoing. There is a bunch of other things happening. So if you are interested in this topic, I really suggest you to go and check. I just checked this morning. It's again, ChatGPT is being considered to be blocked in Italy because of that or that. There is a lawsuit in the US because it made some harm, and so it's the winter is coming, and many interesting things are coming. But getting a bit more to the practice and to the reality, and why it's really so important for all of us to think about that and to even expand this view. Survey. Which answer is right? Any opinions? No. No. A or B. No other options. A or B. The conditions are so that you can choose only A or B. So, who is for A? Raise your hand. Good. Who is for B? Got it. And the answer is, depends where you are from and how it come. So, by the way, this was a quite big experiment done by MIT. The number of people asked different similar questions around the globe were in thousands. So it's a huge amount of people were asked about the same thing. So how it comes, it depends from where you are from. It depends on culture. nothing to do with technology, nothing to do what you think, you know how the computers works or how AI works. And, if someone in US produces the car and they prefer one way or another, do you want that car to operate in your roads because your culture is totally different? Should we adjust and fine-tune for self-driving cars in those countries? To choose the age or something else, which direction to go? No. So that's why important to expand the information. That's why important to include in all those discussions and educate your friends, lawyers, your friends, doctors, your friends that are working in church or doing anything else, because it cannot be decided just by a group of really technical focused people. It's a part of our culture. And again, very fresh, real example happened in US. Cruise self-driving car hit the lady, which was already hit by the other car previously, and it stopped. So as you can see, under the wheel, there's a leg stuck, and the car stopped because it was programmed this way. If something happens, stop and don't move. And then you can ask, your question: is it good or bad? If you have some, first aid training at some point, you would say, yes, this is good because, there might be some serious injuries that, if you move the car, it will make even worse. What if, I don't know, train is coming from the other end, or bus is on the slippery road approaching to you, and then might be, very different situations. So what is if it is a pirate with the wooden leg? Then he's just being stuck for no reason. He would just walk away. So what to do, and what's the potential approach, and what we can do. If you think about AI in your team, in your company, in your, side project, potentially just have in mind that this thing of AI ethics can happen, and you should have someone just time from time thinking about that. It's very, and it is based not just on my, findings and opinions. It's I done quite deep analysis about this, and a number of studies shown that this is the first and really powerful tool. Second, diverse teams. So there is a reasons why sometimes HR or others says we need to have a diversified teams, and it helps. It helps to get different views, different opinions. Documentation and some policy reminders. So if you're doing something really seriously, that can help too, and that can help on the daily basis to do not forget the things. Then if you say, I don't care about AI, I am here to do some, great business, and there are people who will do that. Some will write the code and the things will work. World Economic Forum noticed that, and they even created a toolkit for boards of directors, which in their language is all the key things explained and key working principles explained. So, they will be educated decision makers. As I mentioned, European Union is really heading forward, and they even created a checklist. Could be part of your testing strategy to have this checklist to see how compliant or not compliant you are within what you do with your AI. And the potentially last thing, which is very social again, it's a so-called social license. And if you read again about the same OpenAI, that's what they have. They say that AGI, or artificial general intelligence, if they would be able to create it, it should work for humanity and for people in a good manner, and do not harm that. So that's their implementation of the social license. And then last slide for me, it's there are a bunch of technology tools to start doing that and using those, checking if your data that you're using for training is well diversified, if you consuming some of the stuff, if it is real or if it is generated fakely. and so on and so forth. So thanks a lot.
So A or B? Or as Paul has just wrote in the comments, if you're gonna drift, you can get both. But yeah, guys, maybe you have some questions about AI and ethics. We have one. Try to catch it.
Is there any legal framework somewhere prepared which includes the damages done by the self-driving vehicles? For example, that car that hit a woman, who is responsible? A company, a woman, or anyone else?
And nobody knows, and nobody can answer that. It's big companies are lobbying, and they of course lobbying in the direction so they can produce the cars and get them on the streets. Then society, in many cases, or let's say lawyers, they still don't really understand how this functions, and so is it do they need to track down to the developer who wrote the code, or is it the product manager who said to design this way, or who? So there is no one practice which is well defined and known, and that's, I think, one of the big limitations and problems currently.
Just to double fact on that, there is more than 800 regulations right now in 69 countries. You can imagine what's happening with the AI right now. So yeah. Any other questions? Christopas.
Hey, thanks for great presentation. I was wondering, do you know how big is the market for detecting AI-generated content? And I'm not talking about manual review, but automatic review, such that you could, when you're showing a picture or something on some, I don't know, TikTok or on somewhere else, you could annotate and say, okay, this is AI generated, so the users are aware of that.
I don't know how big it is today, but I really can bet that it will be big, very big, in the distant future. Because if we will understand and we will want real content, real information, we'll need those tools.
Thanks.
Okay, guys, thank you for the questions. If you will have more, please catch Ignas later. And right now we have Herman somewhere there. Yeah. Welcome to the stage, and he's going to talk about NordVPN.com transformation and how they went with the stuff in there. Cheers.
Thank you. Hello, everyone. So my name is Herman. I'm the engineering manager of NordVPN web team, responsible for main marketing website of our company, NordVPN.com. Today's presentation is about less complicated topic, composable web architecture, and how it allows to transform our website. Back in 2000, when I was starting my career, building website was not a complex matter. HTML, CSS, a little JavaScript. More complex websites required PHP databases. However, fast forward to our days, we have wild mix of tools where the choice is really not obvious. It went even that far into this just a couple of weeks ago when many people said, okay, this was a little too much. And the JavaScript, besides its greatness, is definitely not the tool to solve all your problems. The rise of the cloud has changed how we build websites tremendously. So while organizations are slowly but steadily moving into microservices, many traditional websites are still monolithic applications, or worse, they are being squeezed into containers. So now if we take any more or less complex website, we can split it into 4 aspects: the backend, front-end, content management system, and the runtime. Of course, there are other layers too, like experimentation for efficient marketing, analytics and tracking for better business intelligence, troubleshooting for more resilient websites. Because there is so much choice, it's very hard to build what you want. Hence comes the composable web architecture, which emphasizes on modularization, flexibility, and reusability of components. The goal of it is to build decoupled applications, where each module can be built independently from the others, and with the technological choices which are the best for that part of the system. Now we could talk another 20 minutes about microservices. Why are they good? Why are they not suitable for your team? But today I would like to focus on content management part of it. But before that, we would like to focus on several other factors that might influence. Of course, metrics are important, like high availability, time to market, performance of the website, expertise of the people who are going to build it, their skill set, or if you don't happen to have a team, how fast can you hire them? Infrastructure cost, or if you are inevitably relying on open source, community and ecosystem. So the trade-offs might not be visible, and some technological choices might be good first, but they not prove to be working equally when your organization or the product grows. Now, talking about content management system, traditionally they look like this, where content is co-located with critical application data and services. Everything is inside single monolith. Management of the users, search, services, everything is inside. This is, many of you understand, is not the right solution. So in contrast to that, headless CMS systems are of a different architecture. Content is separated from critical application data. There are many systems out there, third-party services, the ones you can self-host even, and in this case, those can be even in a different availability zones. Your application and the CMS have different traffic and can be fine-tuned, very granular fine-tuned. They are also future-proof and allow changing the whole system without major refactoring of, everything. The backend is separated from the content, and it allows teams to choose the front-end frameworks of their choice, like PHP, React, or someday PHP, and then swap it with something else tomorrow. It comes with many benefits. First and foremost, as the name suggests, it's headless, so you have full control of the front-end stack. The CMS system provides content, the backend and the front-end decides how to render it, with which framework you choose to. Moving on, it unlocks composable editing, when page can be built with shared parts and the unique parts. Content editors can change shared parts in a single place and with click of a button propagate into hundreds of the pages. Of course, being disconnected from the front-end stack, it unlocks possibility of high-quality AI content generation, be it high-quality content or digital assets. Many CMS systems have hundreds of integrations and plugins, be it like digital asset management, payments, analytics, SEO, or other tools for experimentation, for example. As well, headless CMS systems provide omni-channel publishing, where with one click of a button, content can be published into multiple platforms on different applications or the websites. Now with this, let me introduce you NordVPN.com's transformation journey. The current website, despite having several modern modules, is very complex. Some of the parts are modern, but some of them are just wild mix of different technologies. However, how the Prime Directive or NormCert states, regardless what we discover, we understand and truly believe that everyone did the best job they could at the time, given their skills and abilities, the resources they had, and the situation at the past. So I would like to focus on several issues. Cumbersome content editing experience. Currently, our content editors are writing JSX. Essentially, they are programming. Next, it has multiple points of failures. Transpilation, translation, caching, databases, very complex. All of this is causing poor rendering performance. Time to market is very slow. Experimentation is slow. And because we have so many different choices on open source libraries, there are many vulnerabilities. I'm sure many of you went through the journey of installing Black Duck and uncovered many Easter eggs hidden deep inside your project dependencies. Many of you are tackling them up to now. The choice of the right stack was not easy. So after conducting various prototypes, we chose the following technologies. For backend, we went for Astro Meta Framework, which according to Google Core Web Vital Assessment Score allows more than 65% of the websites pass those vital scores with excellent marks. Median page weight is 3 times lower than for the websites that are built with Next.js. And with Astro, you are free to choose whatever front-end framework you want, React, Svelte, or anything else. Of course, we rely on Node.js because our application is using server-side rendering. For front-end, we went back to basics, HTML and CSS. Not pure CSS, but with a tail, which many of you might hate, but it allows us to build components that look consistent, have a certain design system, and allows us to build them very fast. We use Solid.js, and we try to fine-tune all the JavaScript what we load to the website. Astro allows us this because it has fine-grained control when and what JavaScript to load during page rendering time, when page is idle, or when certain component becomes visible. This JavaScript, amount of JavaScript on front end, is one of the key aspects which slow down the performance. Every 100 milliseconds costs money and affects your transactions. For CMS, we chose Storyblok. I'll talk about it a bit later. And as a runtime, Cloudflare and Kubernetes. Diving in, the choice brought several benefits. Seamless editing using Visual Editor. Machine learning-based translations using Crowdin with minimal manual interaction. Dynamic, always live, country and funnel targeted pricing, which allows us, our pricing strategists, to update them in a matter of minutes. Experimentation, to be launched very soon. On the dark side, we have planet-scale deployment thanks to Kubernetes and load balancing. We rely on Cloudflare for security and Grafana for monitoring. And all this infrastructure costs just a fraction of the current system. This transformation would not be possible without amazing people working in my teams. My engineers, my engineering team leads, QAs and POs, and of course, our stakeholders from business, marketing, CRO, and SEO, to whom all I would like to say thank you for trusting me in navigating us through this journey. So the key takeaways would be: pick your tools wisely, modularize your website, and stay adaptable for the future. Thank you.
Okay, we have 15 minutes of questions now. We have some time, Herman, so we're going to talk a little bit. I see one hand, right? So let's try. Ooh, I'm good today. I'm good.
It's hell.
Of course. Yeah, it's also one of my favorite topics. So one should not jump into microservices because there's a hype around it. First and foremost, you have to have continuous integration, continuous delivery, good practices in the team with writing tests and automation, etc. Many companies rushed through microservices and produced worse results with much more costs than they should be. Of course, they had benefits because of decoupling. However, one cannot run before one can walk. So there are several critical steps to take before going into this step.
Was it difficult for you guys going into microservices and Kubernetes? What was the story?
So we don't have that many microservices. The main transformation of the website to Kubernetes was relatively not complex because we had great support in the company and great engineers which had, so to say, white label setup which allowed us to build this. Once you have it, it takes time to fine-tune it, but at the end, it's really worth it. You have all your running system under your fingers. You can see CPU, memory utilization. When we are like today, Black Friday, you can fine-tune, have more service up, and then on Monday, lower it down, and you can runtime see your costs.
Okay, any other questions? Yes, Paulie.
Yeah, so I remember that in the older days, there was a lot of WordPress landing pages built in like frontend. Are we still there, or now we completely finally removed?
I wish I would say we finally removed them, but we are going after them one after each other. So it is a complex job to replace all pages. We have a small website, nordvpn.org, 5 to 6 pages, which we built in parallel and then replaced just with a switch. However, nordvpn.com, I don't know how many of you are aware, it's about 8,000 pages big, with all the languages, etc. It took time for us to build a system to have seamless integration. Currently, when you open the website, it's comprised of both worlds, the old one with WordPress and the new one when you open the pricing pages. And you will not notice any difference when we jump around from one page to another page. So currently, we are in the stage when we are building critical mass of components, which allows our content team to migrate pages at scale. So.
Okay, any other questions from the audience, maybe? 8,000 guys, 8,000 pages, can you imagine? And you have dynamic pricing, right?
Yes.
How quickly can you change the prices in different countries, Herman? Let's make Nord expensive today. It's Black Friday. No?
In fact, it is a two-step process. Pricing strategist defines the price, changes in the backend, and hence the content tool republish the page. When it is republished, after cache time is expired, the prices are updated, or we can purge the cache immediately, and then it's immediately live.
I think that not many people know about the numbers in general, what you're doing with the site. Maybe you can share some insights, for example, how many experiments you're doing, how many times are you deploying a day, and so on.
Mm-hmm. Yeah, very great question. So the website is quite complex. There are many parts. We are having several releases every week, releasing several parts of it. And when we speak about the current stack, we have more or less one or two, well, past 2 months, we had 2 releases per week, like shipping 20 features each with each. So it's quite a complex job. Speaking about the numbers, of course, there are multiple teams working on experimentation, content, the blog articles, etc. So many things happen without affecting our team specifically. We run dozens of experiments simultaneously. You will not notice when you open the page, it looks differently, some buttons are different, you see additional banner, etc. Most of those experiments are by design, failed experiments. One of them, like Amazon experiment you've heard about from the board, was super successful. And we relaunched this experiment now in multiple countries, and we're going to expand it with not Amazon, different coupon providers, but this is what we are aiming for. Fast experimentation, validate which one is correct, and double down on these right solutions. Besides that, every quarter, some quarters more, some quarters less, have specific campaigns. in specific markets or global, like Black Friday or New York campaign, etc. So this is also like some things are happening on the background when our content team requests several components and they update the page without us knowing about it. But some of them are strategic, like a rollout or new products. That is a whole team effort from planning, from the marketing to development and QAing and rolling it out to public.
Okay, any last question? Okay, we have two. Let's try.
I already have the cube, so thanks for nice presentation. I want to ask, how much trouble does cross-browser compatibility do you have these days? Like previously, I remember it was quite painful to support multiple browsers and versions. How much trouble it is nowadays?
Yeah, really, really great question. So there are two aspects. Currently, browsers are not the same as they were 1 year ago, 2 years ago. Many of them are running with Chromium, so essentially same browser, despite they look a bit different. But many of those issues are solved. So these wild differences are not existing anymore that much. What exists is new functionality that is released on certain browsers that are not available on others, and they are being rolled out. So because we use a consistent design library with Tailwind, we try to cover, let's say, the most of the cases for the most of the browsers that our website has to run on. Hence, we don't face, I can't say we face that many cross-browser compatibility issues at the moment, because the browsers are different and we try to use tested and well-functioning functionality across the board. But nevertheless, every time there are differences, like Safari on mobile devices is like new Internet Explorer 6, essentially. So many issues come with that, but yeah, it shouldn't be drama every time to fix those. It's just a process. Each time if it is something simple, we would go ahead and fix it. If it is something complex, it requires, let's say, heavier changes. We would check our analytics and we would do decision based on that. How many users with these browsers visit our website? How much is the impact? Is it worth spending an hour of our developer time on that, or just do it for something else and have a global impact?
So yeah, just a note, I'm interested right now. So we can surely say that our site is a lot data-driven, right? Like the changes of it and how we are evolving it.
Yeah. So sometimes when you say we are working on a website, it's just like this. It's a whole monster under the hood. So there's a lot of interactions with different teams, checkout and UCP, the transition of the user from one page to another, that they see same prices, they are not surprised, their coupons which they carry over from our affiliates are applied along the way. So it's a lot of things going on.
Okay, the last one.
Thank you. I had a question. So is there a plan to implement dynamic pricing similar to, let's say, airplane tickets, where you would maybe spot my fingerprint, maybe traffic goes high, and maybe it's worth, increasing the price of subscription for this user in this country at this time?
I don't have to spoil too much, but I have to say there are some research and development works going on into that directions. I have some colleagues who are investigating that area, and we have even some running prototypes. When after 10-page visits, we can predict more or less the user journey and have a personalized offering. Are we there to launch this to public? Not yet, but I think AI is there and it's inevitably coming, and we're gonna have integration in this or the other way into these things and have personalized offering, because that's, I think, where we being in the marketing can make even more money, when we can not just offer off-the-shelf products and pricing, but have personalized, of course, with personalized offering by keeping privacy of our users in mind. Which this is also an aspect where we invested a lot, from keeping the anonymity of the user while still, not breaking the user experience, still running under the hood tracking of, from which country who buys, from which landing pages they go, and where the flow stops, etc.
Okay, thank you, Herman. Amazing presentation.
Thank you.
Next, we have Alina. She's coming already on stage, and she's gonna talk a little bit different topic. Not many tech, right there? No. More management, right? That's my thing. So enjoy.
Yes. So, hello everyone. I'm part of the NordVPN app team. I'm a developer, engineer, but I want to talk about people, about the ones who actually deliver the products, and have some open questions and maybe ideas about ownership, accountability, and inevitable failures that we encounter. I will touch upon self-organizing teams, and the multiple perspectives and how do you leverage them in a team. And also the question of accountability and new view, just culture, and the language shift you need to use in such a setting. And also, lastly, we will try to embrace and understand the human error. So first and foremost, one of the important things in Agile Manifesto is the fact that we should build teams around the motivated individuals. And from time to time, team reflects and tunes in its performance and adjusts. And here we arrive at the simplicity, the cornerstone of such teams. And we maximize the amount of work not done. All of these points flourish in the environment of self-organizing teams. The best architectures, requirements, and designs come to fruition in self-organizing teams. So what are they exactly? You can name them as bossless or horizontal teams. Hallmarks of such teams is the fact that the authority and leadership is distributed evenly among those teams, and information flows transparently and quickly. Employees take as much ownership as they will, and the more ownership you take, the better the quality of the product. And we as working in such teams have the autonomy to shape the product as we go. And this results in the fact that these are lean teams, and we quickly react to the ever-changing situations. But we should not confuse the fact of this horizontal structure and the question of not having leadership at all or having no structure at all. This is not a chaos, but these teams have different structure where people have a say in every step of the way, and these teams evolve with time and depend on the needs of an organization. And here you can see one of the example of decision-making in such teams, and structure of such decision-making in self-organizing teams is more of a circular than the vertical one in more traditional team structures. Like here, you can see the traditional vertical system and the self-organizing team structure with the bottom-up authority. And you can see that even the leadership or managerial positions will take into account the points of view of all the other team members and vice versa. And through this structure, these self-organizing teams can thrive and produce products quickly. And one of the important things in each and every such a team is ownership. So ownership is a question of perspective. We have lots of people, lots of teams, and even in a small team, we have several members. Each and every one of them have their perspective. And the question is, which perspective is most important? Is one perspective more correct than the other? Let's do an experiment. Here you can see a picture of a young woman. You can see a nose, a neck, her hair. And here's another picture of an old lady. Yeah, you see the nose is quite different. The lips are different too. And the third picture. In this picture, you see both of those ladies into one. So both of those perspectives. And I know that some of you will see her a young woman, and some of you will see her an old lady. And each and every one of you is correct. So you need to take all the perspectives into account in order to drive the product. Or another example, if you develop a graphical user interface application, yes? So who is more important, front-end team or the back-end team? Front-end team will definitely have a different perspective of the product, of the timelines, maybe even the quality of the product in comparison to the back-end team. But does this mean that one of the teams should take the lead? The best product will probably be the one that will be a result of cooperation of both of the teams. So here's exactly that. Best decisions in the setting of multiple perspectives is decisions driven by common ground. You find that sweet spot where each and every one of you have commonality, and these are decisions that will drive the products. And best results are results of a healthy collaboration. Each and every silo, each and every team, and even a member have their separate perspective, separate ownership, and separate view of a product. And only then, when all of you collaborate in a healthy and equal manner, you will get the best results, best products. If you do not, this will result probably in a messy product, in the bloated deadlines, maybe a lower quality. It's the setting when one of the view is dominating the other, and vice versa. So each and every perspective is very important, and each and every one member of the team should take accountability. How can we do that? We should do that probably in a setting of a just culture, in a culture of fairness, and this will require a paradigm shift and a language shift. Most of you know the no-blame culture. It's very similar to just culture. In both of these paradigms, no blame is assigned to a person. We promote reporting of errors and honesty in communication. What is the difference in just culture is the fact that individuals are held accountable to their misconducts, to their errors. We must improve upon error making for us to grow. But mistakes are not the result of one single bad apple in a system or a group of bad apples. Misconducts and the errors in the system are a result of the organization and systemical errors. As you can see here, there are different layers of the complex system, and each of the errors must have aligned for us to have a system crash at the end. It's a complex system. And you need to investigate incidents. But investigating incidents in prescriptive way is probably not the best idea. Sending a person who is not inside the situation, who does not know how the day-to-day decisions were made that led to the incident, will not bring you much knowledge, neither about your organization, nor your product, nor your people. Instead of that, we should promote just culture and cultivate accountability that fosters learning in the system. Several ways to do that. You should be fair to the people and hold only accountable for the things they have full authority of, and analyze incidents in light of the future. Analyze not the way and the reasons why they happened. You analyze them for us not to repeat them and to grow the success rates of our system and of our products. And one of the most interesting things is the fact that success is not a given. Success also needs to be analyzed. And for it to do that, we need to have open discussions and fresh ideas. And also, might be a good idea to have some autonomous unit that is responsible for the service quality and investigation of the errors in the system and in your product. And language shift that should ease your way into such a view should come from the old view. And the old view will ask the questions of who is responsible for the incident. The human error is the cause, and the errors are random in the system. Instead of that, you can ask another question: what is responsible? And errors are symptom of an imbalanced system. And the analysis of these errors will bring you knowledge into your system and will let you drive the system to better quality. And human error is just a starting point of an investigation, not the end point. And some of the examples that you can take and drive your investigation into any other error or incident. These questions are more of a prescriptive nature. And these are questions that will let you understand the view that the people involved in the incident took while they were inside of that accident or error or whatever problem you have in your teams. So lastly, we will try to understand and dig deeper into human error. And human error is here written in apostrophe, and it's very deliberate because it is not really a human error. When you analyze the incident, you tend to look at it from the hindsight. And from the hindsight, it is very simple to see. There was a cause and there was a fact. But this is a faulty view of the incident. It discards all the messiness that the people involved in an incident had to endure to drive it to the end result. So you better be looking at the understanding of the human error from inside of the tunnel of the incident. As you can see here, from the start of the tunnel, you see here a person standing, and that person does not know that this incident will result in some error or the server going down, or there will be some production issues, or anything else. And the hindsight of such an incident simplifies the view. What is going on inside of the tunnel is much more complex than that. Each and every time, a person inside of the tunnel constructs some understanding of the situation, does some actions, and the situation changes, and the cycle repeats on and on. And the person inside of the tunnel does not really know that the left tunnel would have resulted in a more positive outcome, or the right tunnel would have brought him better products, but he took the middle tunnel that resulted in a crash. But the person inside of the tunnel did not know that. And in order not to repeat those errors and improve upon them, quick fixes should be abandoned. Like in any other place in life, you know, quick fixes do mostly nothing. And reprimanding people or retraining people is not the solution. You cannot know which people to retrain if you do not understand the reason for the error. Or writing up some procedures that probably would not be followed per se, but they will overcomplicate the even complicated system already right now for the people. Or adding more technology on top of that will probably result in much more errors and much more new errors that you did not predict on top of your old ones. So what can be done? You can start seeing those incidents, errors, as organizational errors. And this incident and errors is a starting point of an investigation of a dialogue between the teams, inside the teams, that will bring you much more knowledge into the system. And leaders, managers should lead by example, because the teams go in the direction as they are led by. And also the accountability and the responsibility should be balanced. And one of the important things to keep in mind is the fact that over time, each and every team, organization, department evolves. And we evolve from the most unsafe systems to the ultra-safe systems. And at each and every level of them, different steps will produce best results for each and every situation. For example, unsafe systems will result in better products with maximum performance and individual competence. Yeah, safe systems will be better off with improving just culture or incident reporting levels. And the ultra-safe systems usually drift into failure very unseemingly. And most of the incidents do not get reported per se. And so for betterment of such systems, you need to analyze the normal day-to-day work and the compromises that we make on the day-to-day level, and build up the resilience of such systems, teams, and organizations. So several takeaways from this presentation. Self-organizing teams thrive in horizontal structure, and multiple perspectives and strong owners drive the success for such teams. Just culture is a culture to foster accountability and open learning in such teams for betterment of products. And hindsight bias simplifies the complex problems, and analyzing such problems from the hindsight is not the best idea. And we should all try abandoning the fallacy of a quick fix So we should embrace hard fixes, because hard fixes are the ones that will improve the structure of organization, teams, and the product as the end result. So thank you a lot.
Thank you, Elena. Yo, I see my engineering managers here. I would like to hear the questions from you guys, but we have already one from Domininkas, right? Let's try. Worked.
Oh, hello. You mentioned about the fallacy of quick fixes, but does the quick fixes no utopia to get rid of that? Because if you can get a quick fix, commit to a long fix, and business is happy, teams are happy, and like I don't know, is there like a utopia to get rid of quick fixes?
No. As you know, as I mentioned, multiple perspectives at each and every question, you know. Even this presentation, it's just one perspective. You need to keep different perspectives in your mind when you need to drive to some conclusion, yeah? And if you have some deadlines, product, you need to ship the product, of course, you need to make some compromises at that point. That is done at the best of your abilities, or at the best of your resources, and so on and so forth. But probably the main idea here to keep in mind and to try to understand the system that you're working in. And once you understand it better, you will be able to produce much better results.
Does that answer your question?
Yes.
Okay. Any other ones? The crowd is silent. Thank you, Elena. And we're going to go into a break right now. We have around 30-40 minutes. We're going to come back 3 p.m. local time, Vilnius time. So enjoy the break, grab a coffee, and see you soon. Welcome back to the last leg for Tech Days, and we have still 4 presentations left, and we're going to start with Domininkas, the head of development of threat protection at NordVPN, and he's going to talk a little bit about ISPs and what they see and what they don't see, right? So have fun, Domininkas.
Thank you very much. Ooh. I'll see if you cheer after my presentation. All right, so the true intro slide is here. So my name is Domininkas, I'm the head of development for threat protection. And today I would like to tell you more about what ISPs saw in the past, sees, and will see about your online activity. And I know a bit about this topic because previously I worked for the company that served ISPs with the ability to provide security for the customers and also gain insights about their customers. So I went to the dark side, now I'm on the bright side. So I'm about the security, so I know how to battle that. Also, there were a few regulations and a few standards released, so that kind of affects this topic also. Cool, so let's start. What is an ISP? So ISP is an internet service provider. It actually is, if you would like to access internet, you always use an ISP. There's like, if you use satellite, mobile, DSL, anything, it's through an ISP. So they always get your traffic, they get you the access, but they can see that traffic. And there are several reasons why they do that. Actually, they do that for service improvements. They have quality of service services running on the agents in the cloud that allows you to get better quality of streaming or any other things. They sometimes offer security. Now, actually, all the ISPs have some security programs. They, it's a big word. They want to sell it to you or bundle and get more money from you. Targeted advertising, also kind of shady thing. So they get the data about you. They understand what are your needs. Like, okay, you're watching Netflix, so probably you need a 4K TV. So we're going to upsell you with a nice margin. And they do that. Customer support. That kind of sounds on their own interest, but actually ISPs, what they do is that they do it just to save money because customer support is expensive, especially if humans are involved. And if they understand what kind of devices you have at home, they might help you faster and solve your problem also cheaper. And law enforcement, some ISPs are regulated, and all of them are regulated, but some of them are required to pass some data about you if law enforcement asks. So they like your data, they want your data, and there are many reasons why they do that. Moreover, there are cases, I'll talk about that later, that they can even sell your data. So this is actually a report from Federal Trade Commission back in 2021 about how ISPs, this is about United States ISPs, how they take your IP address and how they can sell it. So even though that you think, okay, my IP address, how innocent is that? Like I don't reveal anything else. It's when it's bundled in your file in the data broker, it becomes an asset, and they benefit from that. So just so you know. And there are a few things that can stop ISPs from collecting your data. So one is the regulatory requirements. All my next presentation will be about regulatory requirements. No, okay. That was a joke. So there are a few things, like in European Union, we're a big family, and we have 4 magic letters, GDPR, and they comply to that, so it means that they need to ask for your permission to collect that data. What they do, actually, they ask for that, and usually they get it because you click next, you want to get access to get online. In States, it's way, way worse. Like in 2017, the FCC released a requirement, they kind of allowed with their regulation that ISPs can sell your data. So that's what they do. They don't only sell IPs, but they sell more data. And we'll talk about what data they see. And that means that the only true protection is encryption. So it means that it's up to you what websites you visit. Yes, I like it. So we'll talk more about encryption, sadly. All right. This slide is much more exciting than it looks like, so bear with me. Encryption, I mean, we'll talk about encryption in terms of HTTPS, about TLS and SSL, because those cases, if you share email with your public PGP key with your friend from Australia, that's on you. But we'll talk about how normal people would access internet, and they would browse internet, right, through HTTP websites. So let's talk about some history, because ISPs transfer your data from early days of internet, and in wild 90s, they could access all of your data. It was unencrypted, even though the standards were there. SSL 2.0, 3.0 were released, but the adoption was slow. Some banking, e-commerce websites used that. Actually, SSL 3.0 was the most stable, latest release that they used for quite some time. It was deprecated 2016, I think. Yes, 15. TLS 1.0 was released, and actually, there's a funny story behind that, why we use 2 names there, because the SSL was drafted and authored were Netscape, and later on, they wanted to put some distance from Netscape, so actually they called it Transport Layer Security, and they speak that it was more about to appease Microsoft, because they wanted that distance there. But TLS 1.0 actually was not that dramatic difference from SSL 3.0, even though the standards were there, the adoption was really low. And in 2003, we had SNI extension introduced. It's really important for the story, but so just keep that in mind. I'll explain why it is important later. 1.1, 1.2 released, and then we had Snowden revelations when he showed how government, especially United States, can spy on you and how much data they collect. So people start to get worried, even people that not technical savvy. So they wanted, ask like, how can protect my data? And then we had the Let's Encrypt Certificate Authority initiative that allowed more people, allowed more websites to get a free certificate for TLS. So the adoption started to increase. And I think in 2018, we had TLS 1.3 release, which was a major release. That is the current standard of our encryption. And they introduced the SHA-256 hashing, introduced AES encryption. So it was released 2018, and it started to ramp up as a standard also. And I tried to look for numbers. Lately, we had about 85 to 93, depending on which source you look at TLS 1.3, and about 82 to 98% of all the traffic uses HTTPS. So what does that mean for the ISP? That they cannot see anything, basically. They can see a very tiny slither of your HTTP traffic, which probably is more about IoT devices now. So looks like cool, problem solved, but in reality, not. So this SNI extension field that I mentioned is one of the fields that is used in the client hello. So TLS, we'll talk about that in depth later, as you know, starts with the client hello. And that's an encrypted part. And that means that a client is saying that, hey, I want to connect to that, to this domain. And that is visible for the ISP. So they got really interested in that in 2003 when it was introduced. Actually, the point why it was introduced, because back in old days, we could afford one website, one IP, but now we have to save our precious IP, so they need to host many websites under one. So in order to start the communication, you always have to pass which domain you want to connect, and they serve you the certificate for that. Sounds innocent, but then ISPs abuse that a lot. So for the privacy enthusiasts, it remains the last pain point, because everything beyond client hello and server hello then becomes encrypted, so you cannot see anything. But this thing you can see. So you can see that somebody from that IP tried to make a connection there, made a connection there, for how long, and etc. So you can build a richer profile, which makes this a bigger asset. Actually, in 2019, I think it's India and South Korea switched from DNS filtering to SNI filtering to secure their networks, because on DNS you can ask and you cache the DNS response. Here, every time you make a request, that will be logged, and then you can see that. Cool. That was my export there, so you can see, I can see myself where I'm going. So there's a solution. SNI and ECH. And actually, we'll talk about ECH more. So that's the last piece of our security puzzle. Or is it? Dun dun. Actually, SNI is a standard proposed in 2018. So let's encrypt that extension that passes the domain name. That, if we encrypt that, ISPs won't see anything. They will see only your IP, and that solves the privacy problem. But they saw that, okay, the adoption will be slow, will be hard to implement, so, and will be limited to only SNI. What they saw also that there are other extensions in the client hello message and the server hello message, so you can profile that request and answer and say, okay, even though that I don't know the domain, I can guess it based on that profile. So they switched into 2020 to the draft switch to ECH, called Encrypted Client Hello. So that's the holy grail. That's the current draft, and that's the implementation that the browsers, websites, and CDNs are going for right now. And it's only compatible with TLS 1.3, and I'll talk about that later. Why is that important? So when we release ECH, your domains are then private. But let's talk about in depth how ECH works. So on the left side, you see normal TLS 1.3 handshake. There's a client hello. It has some extensions. It has this SNI field that I mentioned. And there's a server hello message. It has some non-sensitive extensions unencrypted, but the encrypted part includes certificates. So that's the important thing, that TLS 1.3 actually paved the way, create a baseline, so we can put the encrypted client hello on top. Because if you would not encrypt the client server certificate, anybody looking on the wire would see that certificate and say, okay, even if you encrypted the SNI, I would see what kind of certificate is being passed, so I will see your domain. So TLS 1.3 prepared that. Now it's adopted. We have good adoption. And on the right side, you see ESNI. So that was the first proposal, to encrypt that little one extension. And I mentioned there are flaws in that. So that's why now ESNI is on the left side. We introduce ECH. You'll hear about that more. Probably you did already. But the adoption is coming out now. So how it works. On the flow diagram, it looks like a normal TLS 1.3 handshake. There is a client hello, there is a server hello, and that's it. But the client hello has the one extension which actually embodies a inner client hello. And if you're looking at that, you can think of two ways. Like some people, Cloudflare, think it's an elegant solution to a privacy problem. They're authors of the RFC also. Some people call it a hack, because like embedding a client hello into extension of client hello doesn't seem so elegant. But actually, it solves the problem. So how ECH works? There are several modes: split mode, share mode. We'll talk about split mode because split mode is the one that's being rolled out and implemented more. Split mode means that there is a client-facing server, a CDN, or we'll talk about Cloudflare in this case, and then the backend server that serves the website. So what you do, the client would actually send a client hello outer, and will include SNI, a field that would name the cloudflare.ech.com. And that's what only you would see on your Wireshark, and that's what ISPs will see. They will see CDNs you connect to. That's kind of, you're hiding that from ISP. Cool, but it's not that nobody would see websites that you're going to. Cloudflare would still do, so you're just limiting amount of organizations you trust. And there's a client inner hello, and that is totally encrypted. And there's a problem in this. That's the first time client and server are speaking. How would the client encrypt something for the first time? So what happens before this TLS, TCP, and etc.? What happens before? Can somebody tell me? Yes. You can generate the keys, but what the ECH standard says, you get the ECH config that includes the keys, and you get it from DNS. Yes. This is so exciting because actually TLS, the whole TLS concept is now going out of this HTTP concept and going to DNS also. So there's a special record in DNS that you'll ask about the website, and they will just ship you, okay, there's this website supports, and this website with the alias through that CDN supports ECH, and here are the keys. Please encrypt it, and you'll be secure. So the client gets this from DNS connection, and then it can actually, on the first attempt, make this connection to the Cloudflare, in this case CDN, and have this inside encrypted. There's a cool feature in that if CDN actually gets this, it gets this message and cannot decrypt, and because client messed up, got old keys, I don't know, he can actually send you the public keys of that website and say like, okay, try again. Not of them, but of Cloudflare public keys. So it gives you an option to try again without the DNS. So cool. This is how it will look like. And ECH got rolled out. You'll be surprised. Cloudflare on September 29, they rolled out, and they said that ECH is available for all plans. It means includes free, which is mostly used. And they called it off on October 11 because things didn't work. A lot of websites broke, and so that's the story of ECH. Actually, no. So the bumpy road is there. You have to fix the things. So in this story, you have to have several things. You have to have a website that supports ECH. You have to have a CDN that supports ECH. And you have to have a browser that supports ECH. So Edge, Firefox, Chrome, they all support ECH. It's as easy as enabling 2 flags on the experimental field in Chrome. So if you enable that, and your DNS supports ECH records, and if your Cloudflare supports ECH, then you can make that secure connection. So there are a lot of ifs in that, but the future is bright. It's there. One caveat that there are enterprises that still rely on SNI, and you have to appeal to everybody. So there's an option that if, for example, you own DNS, and a website, a client will ask about the certain website record, and you see it supports ECH, and you can play a dummy and say, I don't know about, you return NX domain, and they fall back for the option without ECH. So if you own DNS, that means that in that network, you can disable ECH completely. Sad story about that. So how the post-ECH world will look like. Even though that if we passed everything there that I mentioned, browsers, CDNs, websites, and if you use a good DNS, your IP is still there. ISP still see that, and as I mentioned, even though that you don't think it's important, it's part of your file in the data broker. There's traffic analysis that they can do, connection duration, etc., packet sizes, but there are two things that they do, DNS and the gateways. So, as I mentioned, DNS, many ISPs, they own their own DNS. They even pre-configure that DNS on the routers that they ship you. They call those managed routers. And you, if you would like to buy your own, you say, oh, you'll not get that good service with your router. In that case, they're kind of true. But on the other hand, they sometimes even lock DNS settings there. So all your internal network would get their DNS settings, and then they can choose whether to drop those ECH connections or not. So struggle. And if it's DOE, okay. The whole story about DOE also is important. All ECH story does not work if you don't use DOE. So if you use normal DNS, then somebody could see that, okay, you're asking about that on the wire. They can see you're asking about this website, and you get a return. So they will see what kind of things you're asking, and the whole ECH doesn't make sense. So if you want to have ECH connection that you use, you must use DNS over HTTPS. And gateways. So those managed routers that ISPs give you, you pay for them even, and they have these internal services. Those are, embedded Linux boxes that run many services and agents. So what they do, they see your local network. They can see your MAC addresses, and those are very important identifiers for your devices. And they see your local IPs also. MAC addresses are trying to be beaten by Apple, by others, by Android also, due to MAC randomization. But that's only initial steps right now, and that is right now not a solution because they make many things. They use other protocols like MDNS inside, so they could be still profiled as the same device, even if they change the MAC address. So there are a few things. We talked about the encryption and things that ISPs can see, but they are not that lazy on the regulatory front also. So there was an attempt in 2018. A draft was made about, it's what's called ETLS. It is about a enterprise TLS proposal that, hey, everything what we talked about, TLS 1.3 with ECH, could be actually better for enterprises, which needs a better inspection of your traffic. So what they proposed in that, they proposed a middle boxes there that would get your keys up front in order to decrypt traffic. So how awful is that? Like it undermines everything what TLS stands for, everything what we did for this whole history about trying to encrypt the traffic. They say it's for enterprises, but the draft is open for everybody to implement. And IETF actually objected about the name ETLS because it actually ruins the good name of TLS. So now it is named ETS, and the internet called it extra terrible security. So don't implement, don't use it, but it's open. And I didn't hear anything about that now, but you see there are attempts to do that. And I spoke about good name of our European Union, about GDPR, how protected we are, but now there's a good thing going out. It's eIDAS 2.0. It's about many things, but that includes also regulation that European Union is adding to control the certificate authorities that should be, by their law, trusted by Apple, trusted by browser manufacturers by default if they want to operate in European Union. So as we spoke about TLS, part of that was authentication. You have to know that the server is the one that you speak with, is the right one. So you know because they own the key which is signed by certificate authority. In that case, if their friendly certificate authorities are recognized by the browser manufacturers and devices, it passes whole their rigorous process of checking those certificate authorities, and they can get keys and decrypt your traffic. So again, this is a big, big danger. It's actually not resolved. The vote is on November 28th, so soon, in a week, or 4 days actually, they will vote on that. And if that's passed, that means a big no-no for the security industry. And everything what we talk about TLS would not make sense because they would be able to get keys from those certificate authorities that are being trusted and cannot be removed without European Union's permission from their lists. So that's the end. Hopefully I painted the picture how you can, how ISPs can see data, and I showed you that the things that they still can see and will see, even the ECH is rolled out, but it only captures, solves some part of your, things that are still unencrypted. And ISPs will still continue to fight that with their means, and I'm being totally unbiased. Use VPN, because actually all of it is hidden if you use VPN, and that's not a promotion. So I spent some time with ISPs in my previous work. I travel around the world. I spoke with many CDOs, engineers, VPs, and when we spoke about VPN, we said, like, how does that affect your business? How does it affect your data? And the answer was always, it's just so little people use that. It's difficult to set up, so we don't mind losing 3% of our data. So I think it's a good motivation for us to continue to make it very easy, always connected, so people that don't know about ECH or client hello inner and outer, they can still use a pretty secure internet. And if you use VPN, then your ISP is completely blind. But you have to use not their DNS, our DNS also. So there's a way to secure your traffic. So in that secure traffic, you can share all your public life on social media. Thank you.
The future is bright. Use VPN. Any questions? Pavel, yeah, we have to already. We're going to start with Paulas. Mind your head. I'm good today.
Nice. Thank you for presentation. Very informative, very nice. I wanted to ask, do you know a bit like the percentiles of adoption of DNS over HTTPS? Because it feels like everyone is just using plain text DNS, and that feels now like the major part of a problem if you don't want to be detected.
I don't know the numbers, but in preparation of this, I noticed that they were low. And you're right, DNS over HTTPS is not that high adopted still. ECH requires that, as I mentioned, so hopefully with that we'll get more push, but otherwise, no.
And the doc part, can we use DTLS, like DNS over TLS? Is the same?
Can you decrypt that?
Yes.
On the wire?
On the wire, no.
No, then yes.
Okay.
Okay, thank you.
Other question? Not bad.
Thank you very much. So you mentioned that for all that problems with security, the solution is to okay, thank you.
There's a microphone.
The solution is to use VPN, but how can you trust VPN provider?
Oh,
that's a good question.
Which one to trust? You can see that even in ECH, you do not get the total privacy. You just trust less entities that you would otherwise. So Cloudflare owns 20% of internet traffic, and something you have to trust. You have to trust some CAs in order to authenticate those servers. So I don't think that you can have to trust somebody in your life. So whether that's Cloudflare, NordVPN, I think it's up for you to choose.
Okay. Last question, if you have some.
Yes. Okay. So you said that actually, for example, when you do the ECH, still Cloudflare see the domain to which you're connecting. So I'm thinking, could it be possibly that the government and the internet service provider will collaborate and force somehow, like such services like Cloudflare, to show that information?
So there is a way. If they, there are two ways in ECH that you can do: split mode, share mode. So we talk about split mode where there is a CDN or client-facing server, but share mode, you can host a website and actually, but this works only if you host many websites in the same IP. So it means that, and you have to make a public domain name like, arturcoolwebsite.com, and then all your connections will go through that. So if you don't trust Cloudflare, you can trust somebody else there. But there is a danger in that, and you saw the regulations. They might want to collaborate with the Cloudflare also.
Cool, thank you.
Okay, thank you, Dominykas, for a beautiful presentation.
Thank you.
And now we're gonna continue with the security topic as well. We're gonna jump into catching 0 days phishing attacks, and Jan and Jonas gonna be on stage, and Jan will gonna start. So welcome and have fun.
Thank you. Can you all hear me? Okay, so hi everyone. My name is Yen Ting, as said. You can call me Yen, and I'm a data scientist at Threat Intelligence Team, so same as the previous speaker, Dominykas. And today I'm here with my team lead, Jonas, and we will together tell you all about how we catch 0-day phishing attacks. Okay. So I'm gonna walk you through the first and second part, and Jonas will do the third. The question, why 0-day phishing, right? I think we all know a thing or two about phishing attacks as we're working at a cybersecurity company, but we might not be always aware of just how fast these kind of attacks can be organized, can be planned, can evolve. So that's why it's very important that we catch them as soon as possible, because we don't want them to actually survive a day longer in the wild. I'm gonna walk you through a very simple example. I saw a video online with the title, Create a Phishing Site in 4 minutes. The creator is actually using a tool called BlackEye, and he also stated, this is only for educational purposes, so it's the most simple case. And I'm just gonna do the same thing, only for educational purposes. So first step, you gotta choose target brand. Yeah, the tool actually offers you more than just these brands that you see. Probably offers you around 40. You can even customize your own. And judging from the brand you see here, it's probably a social engineering phishing toolkit. Yeah. So once you make a choice, the tool is just gonna generate a website for you based on its template, and all you gotta do is to sign up for the services like Ngrok to generate a public URL to connect to the page. Then you just have to embed that URL into the email that you write so that you can send it to your targets. And once your targets become victims, voila, all the credentials are harvested, and you can see everything very clearly in your backend in the terminal. So now just take a minute to imagine. There are way more sophisticated, way more powerful phishing toolkits in the dark market online. So to reduce the response time to these threats is actually very important for us so that we can protect our users against these threats. Now let's just imagine that we've already caught some 0-day phishing URLs, right, using our solution. What do we do with them? The current solution is that it's a static block list. It's simply aggregating all the phishing URLs from the external sources that we trust. And you can see here, we're actually pretty dependent on these external sources. If they don't update their list, we don't get new lists as well. It's less than ideal, so the more optimized version would obviously be that we make it dynamic. We add in our 0-day phishing URLs, and then we have it closer to the real-time update. Okay, so let's dive into our solution. As you can probably guess already, a data scientist is obviously going to tell you to approach this in a data-driven way. Have a thought about it for a minute. What kind of data is actually out there for you to use or for us to use? First should be naturally the phishing URLs, right? There are a lot of language models out there that captures the relations between the sequences of the characters in the URL. And URLs are also very fast to process. But it has very limited information, and it's easily manipulated and shortened. So, no worries, we still have HTML script. And together with a URL, we actually now have more information that we can capture and turn them into features, and then for the model to train on. Sadly, these features can actually be learned by phishing attackers quite easily. You know, features such as internal link ratio, domain occurrences in the page. Once the attackers know about this information, they can just change their page accordingly, bypass the model. Super easy. And on top, there's also dynamic script, that poses some challenges. But no worries, we still have last tool, screenshots. Yeah? As you can remember from the last example, most attackers actually target those very popular brands. Facebook, PayPal, Bank of America, whatever you can think of that contain very lucrative user information. And if we can have a model that learns the representations of these brands very well, we can use it to spot phishing. And how does that go? Imagining an URL incoming, we gotta first ask ourselves a question. Is this URL known to us? Yeah, if we can find it somewhere stored in our database, in the whitelist, if we know it. For example, if it's facebook.com, then we know it's clean, right? One of the most popular page. Then we don't have to deal with it any longer. But if it's the other case, we don't know about it. Then we just take a screenshot, we process it, we transform it, so that our model can take it in. And let's assume that the model here is already very well trained. It knows, recognizes all these brands that we want them to learn. So that we can ask it the question, hey, do you think the screenshots of this site looks similar to one of those brands? And if the answer is yes, there's a very high likelihood that it's the phishing site of that brand. For example, in this case, it's Facebook. Because we already asked it in the beginning, right? Do you know the URL? You don't know it. It's not facebook.com, but then it looks like facebook.com. So that's how we can determine that it's probably phishing. On the other end, if the model doesn't recognize the screenshots, then we just assume it to be clean. Okay, so let's go a little deeper on the hood of the model. It is actually an image classifier. So what it does is that it intakes all these screenshots, all these images, and it classifies it into brands. Let it be Facebook, DHL, AT&T, or none of them. And how do we train this model? Very important, first step, collect as many data as possible. Our team is still trying very, very hard and try at the same time not to spend too much money to get very high quality data. Example on the right here, all the screenshots of Facebook naturally should be labeled as Facebook. Same goes to DHL, AT&T. And then we search for a very suitable pre-trained model. What do I mean by pre-trained model here? It's one of those very powerful open source models that you can find on Google, Facebook, or some very famous academia institutions. They are well known of being trained on huge amount of data already, so very powerful to start with. All we gotta do is to tweak it a little using our data so that it performs well also in our use case. Lastly, we evaluate the model on the new images so that we make sure that it's actually functioning, it's working. But things never come easy, right? Things just don't work out as well. This kind of classifier still costs us some mistakes, some problems, meaning that it could still create the bad user experience for us that we don't like. Let's take a look at this example. Yeah. It's a login page of Rackspace. Rackspace is a cloud computing company, very similar to AWS. Then take a look at this screenshots on the left. You can see already these two screenshots share a lot of similarity visually, right? So we can kind of understand that the classifier would make a mistake and say that, hey, I think it's a phishing site of Rackspace. So if we go ahead and block this for the user is obviously gonna be upset, it's not gonna be happy, because it's like, you're blocking my page. Then this is the mistake called false positive for us. Screenshots on the right, it is actually now a Rackspace login page, right? As we can see the logo up on the top left corner. But it looks very different than the one in the middle. So if the model has never seen it before, right, it's probably not gonna catch it, not gonna recognize it as the phishing page of Rackspace. Then this kind of mistake, we call it false negative. So how do we train our model more effectively so that it can survive all these mistakes? We adopt a training technique called distance matrix learning. So instead of just having the model learn the features that only able to separate the brands, we wanted to actually create the distances between the brands. This implies that the model has to learn better features, the features that can actually be discriminative, and then group the screenshots of the same brand closer together and push away the screenshots that are from different brands. Yeah? And once we've done that, the model can create this very nice universe called feature space here that can project all the screenshots into the space in clusters. As you can see here, each cluster stands for one brand. From the screenshots of Amazon and PayPal, we can see that they are actually quite different from each other. But our model is still effective enough to group them together because it learns those distinguishable features of each brand. So I think we're successful in this case. Then how do we make prediction in it? Yeah? Imagine a new data coming into the space, the model projects it into the space. And now we know already that this space is optimized so that the similar points is supposed to be very close to each other. And that's why we can try to search for its nearest neighbors and predict it based on the neighbors' target brands. And yeah, and that's it. That's how we make our predictions, and that's what we achieved so far, one of the most powerful solution we have. But we will continue to observe. If anything happen, otherwise, you will see me probably in the next tech talk. All right, so with this slide, I just want to say that we can also add in other kinds of models, such as logo detection model. And together, all these models can probably make better choice and reduce the false positives and false negatives further for us. I also want to spend the last minute to talk about the data challenges. As in all data projects, data is key. If you don't have a very good quality of data, your model is not going to be well-trained and perform. So first of all, you really should take out all these error pages, all these half-loaded pages. Then we also have to make sure that we filter out those screenshots that are not as brand representative. Yeah? For example, the ones without the logos. Of course, we can always argue you can have the model learn enough signals from the background. But then again, it would turn out that Netflix and Roblox actually have very similar backgrounds. So it would actually confuse the model. On top of that, we also have to deal with tricky cases. It's not always easy to label a screenshot to one or another. For example, the one in the middle you see here can be also labeled as Microsoft or Outlook, labeled as both. Okay, so I think that's it for my part. Let's welcome Jonas.
Thanks, Jan. So we have a solution, right? What happens next? Of course, the whole goal of automation is to stay relevant. Imagine trying to predict house prices in Vilnius with prices 3 years ago. I wish. Try using GPT on language trained 500 years ago. It won't work. So the whole goal of automation is to be reliable in production with the newest data coming in. Also, you want to move in maybe to new projects and make this model self-sustainable as much as possible. Let's deepen the first thing. I hope you all understood from Jan how important data is. So when importing data, make sure to trust the source. Check what you're getting. Is this what you expect? Is it drifting or not? Because if you miss out on this step, everything falls apart like dominoes. Bad data equals bad models. The model is just useless. So really delve into data. When you have pipelines for automated data collection, it doesn't mean that it's ready to go to the model. What you have to do is clean. Again, as Jana highlighted, data cleaning is as much important as the collection itself. You want to discard, in our case, false images, brands that have misrepresented images that has brands that are not actually relevant to that image, maybe half-loaded pages, maybe some data is missing, there's no logo. So spend time exploring, summarize the characteristics of it, and that will help you understand in the future when your model makes a mistake or is predicting something, why it is predicting what it is. And always try to, as I mentioned, yourself understand what data are you working with, because if you don't understand, you cannot expect your model to understand or even understand the predictions that the model makes. So you have data, you've cleaned it, you are ready to retrain your model. Of course, you can go just the easy way, and since you already have a model, just add some more data to it. You can move one step further by automating the hyperparameter optimizing, which simply enables model to discover new spaces. You can also try training few models at once and compare them against each other. As Jan mentioned, there are a bunch of pre-trained models. Try freezing some layers, only training the latest ones, and this is the space where there's a lot to explore. So easiest way is, of course, just to reuse same model, just new data, or add some extra steps to it. So you have good data, you've trained the model, but how good the model is. One statistician said all models are bad, some of them are useful. So the question you're trying to answer is, how useful is my model? And usefulness depends on the problem and question you're trying to answer or solve. Maybe what's useful to you is not useful for the product you're trying to work in. So align the metrics with your business goals, your problems, and try to select metrics that are relevant for your problem. If it's classification, of course, use traditional accuracy, precisions, F1s, regression, mean, absolute, squared errors, the usual stuff. And of course, there are many different problems that come with their own set of metrics, like anomaly detection, ranking, clustering, forecasting. All these problems comes with their own set of metrics to check. At this point, you're pretty happy. You say, yep, my model is useful. I want to deploy it. Deploy it means storing your model somewhere for some services to be able to pick it up and use it. So this is where I would say software development type of deployment comes in. So use CI/CD. Of course, test everything. If, for example, our case, we support some number of brands, we have a CI/CD job that tests number of images to make sure we classify like Facebook, Amazon, Google correctly, and do not block things we don't want to block, because that will be very bad for the user experience. He will drop our services, we'll lose a client. So while doing that, make sure you document everything. When did you deploy? What data set you used? What data was in that data set? When was it collected? What resolution was in it? What parameters was used for training? Everything, because if something goes wrong, you always want to go back. And when you go back, you want to check, hey, what happened here? What's the issue of that problem? And while deploying, there are many different platforms to deploy. Make sure to select the one that fits your use. Is it scaling? Can you roll back easily? Can the service you're going to serve the model can pick it up easily? At this point, you have model deployed somewhere. What you want to do is make use of it to your customers. So model serving is a step where basically you enable people or services to get use of your model. And after deployment, let's say we have deployed somewhere, I want to serve it. Bless you. What happens next is, this is a really, really big step, and I think it involves more team than only data science team, because you will probably need some help from DevOps, from data engineers, and even developers to orchestrate all of this flow. Where have you deployed? Is it served the way you want it to be? Do you get the metrics you want it to go? And think about orchestration. Think about workloads. Think about response times. And make sure you have metrics to back it up and to be the whole solution to be crash resistant and visible of all possible issues. Monitoring. When you have deployed the model, when you serve it, at first point it may work, but it's a subject of change. So what you want to do is either verify that it's not changing or be visible of the change. So what you want to do is compare not only the model, but the service. Maybe you want to check the cost of the service. What resources are you using? Are there any outages, disruptions, everything like that? So I would say that you could split the metrics in checking model performance, so how good is the model, how useful is it? The other one is about the service. Is my service healthy? So that like third-party things come in, AWS services come in, and so on. Because imagine you have one service. In our case, let's say we depend on reading some data in our database. And for some reason, that fails. So because of one thing that's failing, everything in our service fails. But if you know that with monitoring that there's a spike in this case, I better scale it up. Or I check what's happening with it. So this enables me to intervene and act on it to make sure that my solution is working flawlessly. Reports and alerting. I would say it's just another small step on top of monitoring, which basically lets you act on those spikes, on those deviations from normally what you would see from data. This simply enforces you to set up alerts Some of them you can have on the spot. Some of them will be understandable in some time, like what's the amount of URLs I expect in a day on Saturday evening. At first, when I have not deployed my model, no idea. Then I see, okay, this Saturday I had this, next one I had that, and I can create with some kinds of notification system for myself. If it's above normal, I trigger alert saying, check this out, something's wrong. Another thing that's really important about reports is more teams may be interested in the reports you make, not only data science team. Maybe stakeholders, product owners want to know how are we doing with our solution. So what you do is, instead of answering questions like, hey, how many phishing sites we blocked in users from Italy in the last 3.5 hours that see an ad on Facebook? I don't know, but I can enable anyone to look it up by having dashboards with filters, and I answer all of them questions. So having all of this done enables to have crash-resistant platform for machine learning model automation and deployment. And I guess the biggest tip from what we experienced is try starting slowly, and by slowly I mean automate few steps, add another, one by one, until you have everything working. Some tips from us, of course, if you want to be safe, as Dominykas mentioned, use VPN. And inside VPN, you'll find threat protection feature, which saves you from phishing attacks, from malware downloads. So basically, it's just free SafeLog. Always check the source. Don't click on suspicious link, like my mom, which is a victim. So if it's too good, it's not true. And the last one, the one I highlighted again, spend time on the strategy and design of your whole system. Create a plan, write documentation. If you do that, it'll go smoother. That's it, and we can have some questions.
Yes, Jan is coming too. Okay, so we have one question in Slack, and basically it's the same that I was thinking as well. How fast we are when brand is changing, website is changing from the image perspective?
So imagine Twitter, right? It was Twitter some time ago, now it's X. So it boils down to data collection part, and we want to deploy models as fast as possible, as frequently as possible. Some companies deploy it every hour. In our case, we aim for each week. So if we monitor, for example, data drift, we can see, hey, look, this brand changed this representation. Let's delete all the data, add new one, retrain.
Can we do it in 1 hour? When? Okay. Next question.
Yeah, so now I know that you're going to support 500 brands. Oops. Okay, yeah, and basically the question is, I think the best model in the world would be like this one, which supports the most brands, and which is very accurate. So how do you think, how many time do you need in order to support like 10,000 brands? I mean, it depends from automatization, from money, from specialists, combined, approximately, like how many time do you need?
I mean, the thing is, most threats or more efficient attacks are actually just, targeting all those popular brands. That's within very limited set, probably around, 200, 300, and it also changes through time, right? So it's actually more important that we spot what are the targets brands currently are, because if you don't recognize them, you're not actually catching phishings. So.
Okay, I get it.
Okay, other question? Yep, let's try. Awesome.
Yeah, so I'm a bit interested in the the cost of this system. So, for example, how long does it take for you to run all the detection algorithm if you need to do the image analysis and so on? What's the lead time for a person until you clicked on a link and now that we analyze that it's possibly bad or good?
You mean how long does it take to train the model? Or?
No, not the model, but when I'm using the service and I click on a link, how long until you know that it's okay or bad, from a service perspective?
So right now, yeah, you go ahead.
I know for sure we have metrics for how long it takes time to make a prediction.
Yeah.
So it's around, on average, from getting URL, taking screenshot, making prediction, it's 0.6 seconds. But to answer the time between you going to a page and us responding, I'm not sure.
Yeah, okay, nice. And can I add that tiny bit? So how many GPUs are currently in the works doing this?
Actually, surprisingly, just one.
Just one? Nice.
But yeah, as we're collecting more data, I'm expecting that to multiply.
Thank you.
Okay, Rytis? Yeah.
So if I understand correctly, right now, basically the idea is that we are getting the URL itself, load the page, then render it, and then do the all the machine learning magic. Is there any benefits to be had if we actually would actively probe the URL? So for example, I don't know, like fill some random stuff in the password and username fields, try to load and see if the errors are like the same as the original website or different, and maybe that could be even more accurate things.
So basically what you're saying is to predict if it's phishing or not based off how a site responds to login credentials.
Not necessarily just login credentials, but even like actively probing the website or whatever phishing link, not just by rendering it, but by actually trying to navigate via the pages, trying to log in with fake credentials and all that.
I mean, I guess it's a space for exploring, but I would suggest that anything you would enter, they would just say thank you, like with no errors.
So that's actually kind of a indicator already.
Okay, any other questions? Okay, the last one, Lucas. Sure.
So Pavelas asked about the inference time, and you said that it's 0.6 seconds. I assume this is on the back end. I mean, when I visit, Nord Security actually checks this URL. Is this correct?
Again, so when you visit URL, the whole flow is like a bit bigger. We have some services working in, and phishing is just one part of the big service. So much stuff is happening when you go to URL, and one of those stuffs, after some if, we check this URL with phishing ML. We do some checks behind, like is it in our lists of known URLs, bad URLs?
Okay, my question is, does it happen on the server or like locally inferred on the device?
On the server.
Okay, that's impressive actually.
Okay, thank you guys for the questions. Big round of applause to amazing talk. Yeah.
Thank you.
Thank you, guys.
Thank you, guys.
And now we're gonna deep dive a little bit into more data stuff. Christina is coming here on stage, and she's gonna talk about the anomalies and how to detect them. Let's start.
Yep. Hi everyone. I'm Christina, as Marius mentioned. I'm from Quality of Service team, and today I'll be talking about a very interesting topic. Well, at least for me, maybe after presentation you will be interested too, so we'll see. But the topic itself is about anomalies and what kind of challenges are associated with it when trying to detect them, and how we can potentially use anomalies for our advantage or in our analytical processes per se. So firstly, I will introduce a bit about anomalies themselves, their significance, what kind of types are there, and similar like that. And then again, I will continue with those challenges that I mentioned. And I will dig a bit deeper with the complexities and what kind of things we encounter while catching anomalies. And I will showcase one of the examples, what we did within our team last quarter, and how we can even more expand on that topic as well. And then again, I will finalize with some futuristic ideas maybe, or how this could be escalated further on. And yeah, let's move on. So I think the topic itself emerged from the need to conveniently catch deviations from user deviations from the norm. So immediately, as a data analyst, we have two questions to answer. So the first one, what is the threshold, right? What is the norm for, say, some specific location and their users? And the second one is, how often does these jumps or these drops do happen? And should we be concerned? So how deep do they go? So if you have univariate time series, as you can see on the left side, it's pretty straightforward to identify those. So we can see where the dips are going on. We can ask even more questions. Why does this happen? So on and so forth. But if we have multiple locations and multiple locations connecting to those locations, and we want to analyze what is happening at that specific hour of the job, then it becomes a bit more confusing and challenging to decrypt, right? As a data analyst, to put some statistics over that. So that's how the idea was born. And then, of course, there are different types of anomalies that do happen, say, taking the same users and their statistics in different countries. So there are just kind of the jobs that do happen occasionally. There are the ones that can last for longer periods, but it doesn't matter the type. All of them could help us to answer some of the deeper questions. So say from data quality side. So if there are lots of drops that do happen for some specific location, so it might indicate that, okay, we're missing some of the data, or there are some discrepancies other than that. So we can also identify those kind of challenges that do happen from the data side. Another thing, if we would track those frequencies of drops in the data, then we can identify some hot locations that are very, varied or very volatile, and act upon that over some period of time. Another thing is that if those anomalies or drops or increases do happen, maybe there is a way to predict them, right, to happen in the future. Because, for example, if the drops do happen in a very sparse way for some period of time, and after that there is a trend that is going on that the users drop like very low, so maybe it could signal us that, okay, we should put more attention to that location. So the process itself could be less reactive, more proactive. And the fourth point I noted here is continuous improvement. So I think it kind of aggregates previous 3 points, and it helps us overall to say, well, to put a label on what is normal, on what is not, and how to improve our existing processes on top of that. So, of course, with catching and trying to put statistics on all of those anomalies that do happen, we have a lot of challenges that are associated with it. I did mention that we have, of course, multiple locations. So if we want to take users for that location's recommendations, or say CPU, or go deeper and go for the statistics for a specific server, then the scope really broadens, and it's really hard to do it, of course, manually, and we need to find some kind of automated solution for that. So this is one of the challenges that comes along. Another one is noise. So say we have, again, some location, and we see that we just put some alerts, right? Say if the users deviate from average per 20%, right? And we get those alerts very frequently, but when we open the dashboard or whatnot, we see that, okay, this is quite normal behavior for that location. So if the threshold is too narrow, or the interval of that threshold is too narrow, it could signal us that, okay, we should maybe broaden that, but maybe in that way we won't catch an anomaly. So there is a fine line what threshold is the best one, and that's why the noise comes into as, again, one of the challenges. Now, variability. So for some locations, users could be more or less stable for some time, and you put a threshold, you go with that, but after a while, we either add some servers or anything else happens. Maybe some of the users rise unexpectedly, so the threshold for longer periods of time wouldn't work that great. So again, the very dynamic data trends that do happen indicates us that we need some kind of very adaptive solution, very adaptive threshold for those kind of things. So the third thing. And the fourth worth mentioning is data quality and quantity. So say based on historical data, we want to define what is the normal user behavior, how they move throughout the day, throughout the month, or overall. So the first thing, of course, we need lots and lots of data to catch those seasonalities or whatnot. And we need that data to be of the best quality. Because, for example, if something odd happens in the server, in the location, whatnot, maybe at the moment of the draft, we're missing the data. So this does happen. So the data should be to the best quality and so that we, as a data analyst, could base our insights and on very qualified data and be strong with what we would suggest for other teams. So, of course, there are a lot of detection types and ways, but I tried to kind of categorize them into three main ones. So the first one is confidence levels. So it's a similar example as I was mentioning with taking historical data and trying, based on those trends that did happen in the past, predict how this could evolve in the future. So we put a threshold, the lower baseline, the upper baseline of where if the trend would skyrocket through that baseline, then we would consider that as an anomaly. But it's really, hard to implement those kind of models to the best accuracy, because then again, it's like forecasting stock prices or anything like that. So it's not very assured way to do and to decide the spot if, say, this location is challenged or not. And another thing is that for predictive algorithms, say, as Prophet, Facebook's Prophet, it can only work on univariate time series, so it doesn't take into account the recommendations, for example. So we were searching for such solutions which could involve taking lots of different data into one place and trying to put something of that. So this is one of the things we tried to a bit forecast, but then we moved on to another one, which is statistical profiling, which is loved by mathematicians. So it's just simple means, medians, rolling means, whatnot. So this is really great for a baseline to kind of put ourselves in some kind of baseline, what is normal. But then the main drawback is it doesn't catch local outliers. So if we have one drop of the data per day, the average still is gonna be more or less normal. So it's really hard to catch those cases based on this category of detection. And then we moved on to the clustering-based approach, specifically unsupervised approach. So why this is really great way to kind of answer or tackle that question, that issue which I was mentioning at the beginning, because in the unsupervised models you do not need labeled data. So which kind of data point would be an outlier, right? So there are, of course, different cluster-based methods, say k-means or whatnot, but they usually need, for them, you usually need to define a cluster size. And for such dynamic locations, if you define fixed cluster size, it can really does not work after a while. So we are putting ourselves into some kind of frames, right? But there are another algorithm, HDBScan, which does not apply for all of those kind of boundaries which I was mentioning, because it doesn't take into account cluster size. Overall, this is really great algorithm because it doesn't assume anything from the data prior training on that data. So, for example, other clustering algorithms would take the data and would expect like some kind of spherical clusters and so on and so forth. But HDBScan adapts to the data which you feed it And based on the densities of the data points, it decides how many clusters there should be. So it doesn't matter what kind of data do you have or for which period it takes it, and it tries to adapt of how, like, what could be outlier based on the data. And of course, there are some parameters which you could tune. For example, minimum cluster size, and et cetera, but this could, you know, kind of be explored in the future as well. Another thing is very important. HDB scan actually can form hierarchies. So these hierarchies basically define when the cluster, if you take all of the data points as one cluster, when the cluster started segregating into separate ones, and what we can tell from the data inside those clusters. So based on that hierarchy, we can basically say that the model performed good or not, because for HDB scan, it's not really that straightforward to evaluate if the model performed well based on some of the techniques that are used for other ML models. So if the hierarchy is nice and the clusters are separated, looking at it, then the algorithm is considered to be pretty accurate. Now, in this picture, I would always, also when I was explaining this to my team, I would say, okay, imagine the volcano, right? And what is above the water are those clusters. And this is basically what it is, right? So anything that is not in the cluster could be considered one or the other way an anomaly. So now this is a very great example how the algorithm, the clustering algorithm, which I was mentioning as the k-means, is a bit not, how to say, adaptable to our needs. Because say we kind of, for this algorithm, we say, okay, let's take 7 clusters or more, and let's aggregate data. So as you can see, it didn't do that accurate of a job compared to the HDB scan on the right, because it adapted to odd shapes, weird shaped clusters, and it's also identify noises or anomalies per se. So these are the great points. And of course, the noise is also a very useful thing to be aware of while detecting anomalies, especially with this algorithm, because actually it's an abbreviation for hierarchy density-based spatial clustering of applications with noise. So it takes a noise into consideration, and it is a byproduct of the clustering process itself. So actually, there's the 2 things that are most useful from this algorithm. So immediately, when you start running it right, it puts, as I mentioned, data into those kind of clusters. All of them have labels. If there is a noise or there is an outlier, it segregates into a separate cluster, which is -1. And then for all of the data points, it gives a probability or an outlier score, which is from 0 to 1. 1 being that it's pretty sure that it is an anomaly. So we are not limiting ourselves to any boundaries. We have range of values, and we can select, okay, we want just really, really anomalish ones. So let's take a threshold, as I did here. Let's put it like, okay, let's take points that are above 0.8, and let's start from there, because these are the key ones where the anomalies, which are clustered as really, really true anomalies. So we can immediately start seeing some statistics or results per se of that clustering process. So say in this example, okay, in Vienna, there were like 300 points, data points that were less than 0.8 and 12 that were above. Okay, maybe lowering threshold would help us to identify even more troubled locations or locations that are really sparse with their data. so yeah, this is one of the key points, how this is really useful for us to identify what is normal or what is not, and based on all of those metrics in one place. So this is just a simple, I would say, case scenario. So let's take recommendations, CPU, RAM, whatnot, users. I take just few here. We also added how many servers are down in that location, whatnot. So it takes into account all of these points hourly, and it classifies each hour as anomalous or not in that location, in all of the locations. So I just took here 3 anomalous points per se, which had the highest score. So as you see, at those specific points of time, there are some, well, data is a bit sparse, it's a bit fluctuating, and we can immediately say that, okay, something odd is happening. So this was done actually just for 2 weeks. We can expand the period for a month to catch maybe some seasonality that is happening, or maybe the users do depend on the week of the day per se. So we can try all of these approaches to fine-tune the model, but the idea is pretty much the same. Now, I know this is like just a scratch of the surface for anomaly predictions. So as I mentioned, we were trying to find some kind of method which would help us to do it in an automated way, in effective manner. So that's why I noted efficiency, because otherwise we would need to surf around all of those metrics, all of those locations, and try to pinpoint, okay, this looks odd, this looks odd. So it's not really efficient doing that. And another thing is that it helps us to, based on previous undetected anomalies, it helps us to identify, okay, maybe it could happen in the future as well. So we can prepare or just put more attention to those locations. So just reiterating my previous point. Another thing, we can catch the moments, say, adapt to current user trends that do happen, and say, put more resources in one or another location, more depending on the day or on the month. So there are many options of that, but just wanted to mention this one. Then again, for the security reasons, of course, abusers sometimes try to mimic maybe normal user behavior, and with the outlier scores or whatnot, we really catch those local outliers, which indicate us, okay, this is quite similar to what is expected for that hour, but not really. So let's classify this as anomaly, or let's look further on. So we can catch how many times does this happens, and go from that. So this another thing we can experiment on. And of course, decision making. So anything data-based should be clear, or should be really of the best quality, right? Quality of service. So we need to really dig into the reasons of anomalies, right? So maybe it does happen occasionally, but should it be like that? So all of these questions could be answered if we would have all of this pool of metrics and grouped them in a certain way that it would be easier to identify the most hot points. And I found this quote somewhere. So I wrote some wise monk, as I don't want to get credit for nobody on this case. But I really think this is the main thing I wanted to leave you with. So the future of anomaly detection is proactive and not reactive. So this is really what I see us, either as a company or as our data people say, doing in the future. Because now we see we react, right? But there are ways, and we can just work on that to prepare for those type of cases, or to be even aware of, or to catch them in efficient manner. So yeah, this is the main idea that I want to proclaim for you, and maybe there are questions.
Wallace is on fire today. He has a lot of questions, and in any presentation. Okay, let's try again. You good?
Okay, very nice presentation. Have you already had some interesting scenarios where you captured something before it was actually detected, and maybe you have something to share?
No.
Sad.
Yeah, like right now we do have just a unified one big dashboard where we identify those locations where anomaly score is on the higher end, and we try act upon on that. But then again, we worked on that for a really short time, so this is like a future of it, right? So this we potentially might do.
Okay, any other questions? No, I have one though. Just random thoughts that I was listening. Can I use HDB scan
yeah.
for trading?
For trading, I mean, with ML there are no limits. I think I will try this myself as well.
Okay.
Yeah.
Good.
I will tell you
Awesome.
what-
So thank you, Christina, for your presentation. And we have the last speaker, the one and only Mindaugas. He's going to talk about the passkeys. What is it? And yeah, enjoy.
Enjoy. Yeah. Hello. Is it okay? Yeah. Hi, I'm Mindaugas. Like I will talk about passkeys, and since Drafting Gods decided I will be the last speaker today, so I changed the topic from passkeys to passkeys one-on-one. So it will be in the one-on-one style. And I think it was a long day, so I will try to keep it in as plain English as I am able to. So let's begin. Since it's one-on-one, I want to put us all on the same page, and I have several slides about that. So first of all, about identification, authentication, and authorization. Yeah, these words are used interchangeably, but they mean different things. And I want all of us to agree what do they mean and what actually it is. So identification is the first step, is performed by a user who provides some sort of credentials. Usually it is a username for the remote party. In case of passkeys, we should call it relying party, and he claims to be someone. Authentication is a response from the remote party or relying party in order to make sure that the user is the one he claims to. And the authorization is totally different topic. It's about like permissions. For the authenticated user, whether he is allowed or not to do some things. So first identification and authentication, that's login password usually, and authorization is about like permissions and a bit different topic. Second thing, I want to remind us all about the factors of authentication. They are usually divided into 3 groups. One group is something one knows. It might be like password, grandma's birthday, name of the pet, you name it. Second thing is something one has. So it might be like a device, for example, USB token, phone. Here is also OTP mentioned, and as a side note, I would say like OTP is not a second factor. OTP is a way to verify that you own the authenticator which generated that OTP, which is bound to your account. So it's like transitioning thing. OTP by itself is not a second factor. And something one is, like it's a biometric data. It can be finger scan, face scan, eye scan, voice scan, etc. But it's like biometric data related to the person. So let's start. First of all, passkeys are like proposed from the FIDO Alliance, which stands for Fast Identity Online Alliance. And they try to make some open standards which are more secure, simpler to use for users, and more easy to implement by relying parties or service providers. Here are some of the board level members of the Alliance, and there are numbers more of non-board level members. So the big names are here, and standards like will be implemented. I will like just stand like this. Okay, so the passkey. The idea behind the passkey is to get rid of the first authenticating factor, that's something one knows, because as you've heard 2-3 presentations again, like something one knows is very vulnerable to phishing attacks. Like people are lazy, they tend to reuse passwords, etc., etc. So they decided to put a use of the public key cryptography and to replace the something one knows factor. And it implemented in the web at a large. So I hope this is the most tech fancy buzzword slide of my presentation. Just once again to make us all on the same page, it's about public key cryptography. And without going like wide into public key cryptography, because I represent Cybersecurity Academy, they have nice courses. If you want, ping Sigita Jurkinaitė and join some lectures to wide. But here actually it is use two keys, a key pair. These keys are mathematically related. One is called secret and should be secret to the user and known only to the intended user. The other is public, which can be distributed freely. And the whole flow of signing is the user takes some object of data, for example, document or whatever, challenge. He calculates a digest of that data and then uses his secret private key to transform that digest. Then he combines data with the digest, with the transformed digest, and sends to the receiver. Receiver, upon receiving, there's two things. First of all, he takes the object and calculates the digest with the same algorithm the sender did. So he gets a plain digest. Then he takes a transformed digest, applies a public key on that, and if that digest was transformed with the related, mathematically related secret key or private key, then that transformation is removed and he is left with the two digests. And if they equal, that means that the object was sent unaltered by the person who has access to that private key. Whew, hardest part done. So FIDO2 is a project which is made from two things, WebAuthn protocol made by W3C and client authenticator protocol. And yeah, that's it for that slide, because we will make it easier. I have a picture of the same. So here is the idea, here our device is a laptop, for example. So a user via browser, because WebAuthn is web API, web protocol, so authentication is done via browser. He asks a relying party something. Relying party gives something. I have the sequence diagram later, so I won't speak here more. But the main idea is that the authenticator, the thing that actually applies passkeys, can be either on board on the laptop or remote, like external one. Both are supported by a FIDO project and the standards. So as I said, the WebAuthn is a browser, and it should be supported by browsers. Here is some nice thing about phishing and about security as well, that if a person's, for example, if our clients use passkeys, not passwords, so the only thing on our database to store is some random ID, which is different by each relying party, so most probably used once, and a public key, which is public by its nature. We don't have to store anything secret, anything I don't know, vulnerable, etc. We can even make our client database public because there is nothing secret there. That's a side effect of using passkeys, which I like. Also, there are two protocols. In early days, they started with the now called CTAP1, before it was called Universal Two-Factor, which was actually the second factor protocol. Now it's like a more wider protocol, which can be passwordless, single factor, multi-factor. It's like covers all the scenarios, and current version is CTAP 2. First bullet point, it's buzzwords, because I wanted to be fancy and like agnostic regarding key material is managed. But actually, what I wanted to say here, that the authenticator, the device which like manages passkeys, can be implemented either in pure software or on a platform, for example, involving TPM on a platform, or can be like totally roaming like a different device or a USB key, for example. Here is the sequence diagram I said. What is interesting as well, in DevOfn, actually there is one sequence. It doesn't differ much whether like it's a login flow or register flow. Just a difference, a bit data which is sent, but in general, it's a client device asks relying party for a challenge. That's some sort of random data. The relying party provides with the challenge. And if a user is registered, so relying party already is aware of the public key it uses. If user is registering, then it will be first time. And the answer is like the signed or transformed challenge which you received from the relying party, and that means like this is how we authenticate people with these passkeys and involving public key infrastructure. And of course, like I will talk about it a bit later as well. Here is like in the middle, like user interaction is needed, because without user interaction, all this silver bullet thing with the passkeys can go wrong. So here are like the points. This authenticator can be used in a single factor mode. So since it's a public key cryptography, it has to be the second of the possession factor, because no human is able to like remember at least 32 bytes of data and make some mathematical transformations by heart. So it's a device. So standalone passkey is a device, second factor. And here it comes like interesting thing that I noticed myself only when preparing for this presentation. As a standalone factor, the second factor someone has is quite weak, because it has no relation to the user. It has a relation to the device, which is related to the user. But in general terms, like it can be any user having a device. And for example, if like a phone or USB token must be stolen by a malicious player, then like for an unlocked desktop, there are no like criminal actions to be taken. Just anyone sitting at that computer is already authenticated. So for my opinion, like a single factor mode is no-go with the passkeys. So we have a multi-factor mode as well. Since passkeys are something one has, we left with something one knows or something one is. And the core idea of passkeys was to get rid of the factor someone one knows. So to put as a second factor, the factor you kept trying to get rid of sounds like a nonsense to me as well. So the only viable option for me, in my opinion, to use passkeys in the multi-factor mode with the biometric someone one is combination in two-factor mode. Maybe too much buzzwords. As well, like passkeys are flexible, they can be used either in single device mode, so not transferable, and they can be used in a multi-device mode as well. Here is like the passkey, the A is stored somewhere secure in the cloud, and it can be distributed via my connected or registered devices. Here is optional, but in my opinion, very important thing. If you make a copy locally on some local your device, for example, computer or phone, you should make this anchor thing here as CNB, like make it device bound, in case like just pure copying of it won't make sense on another device. By the standard, it's optional, but I think it's quite essential. Oh, and Q&As now. Actually,
yeah, we're gonna have a Q&A first.
Okay.
Any questions from the audience? Because I didn't see any in Slack. Okay, we have one from Rytis. Low-level guys are active
no
today.
to Povilas. He's
Okay.
like out of
Ready?
limits today.
Ready? Hey, I'm pretty good. I'm pretty good today.
You're awesome. You should join
Rytis,
basketball team.
Go.
Yeah, I have a question. So if I understand correctly, passkeys are classified as something one has, or am I mistaken?
Yes, because like, as I said, they can be classified as something one knows, but you will have to remember either like 32 bytes or like 2000 bytes in case of RSA of your key and make a transformation by heart, because then you will see challenge, which is 32 bytes of data as well. So if you are able to, like it's about for me, but I think without a computational device, it's not possible. So it's like equals something one has because you have to have it.
Okay, so that was my actually question.
Okay, Lucas, have another one.
Thanks for the presentation. I have a question. I got a bit confused about when you mentioned that we should make the passkeys device bound.
Yeah.
What does that mean? Because as far as I know, the passkey is just like the private key, and how can I make it device bound?
Actually, there are some ways, but the easiest way is, for example, to use the TPM, the Trusted Platform Module. You know, the idea is like TPM, it stores your private keys and they are not extractable like hardware, from hardware. And your local copy, for example, where you save the passkey, you encrypt it via TPM. So on local storage, it will be encrypted with the key which is not extractable from hardware, for example. If you take that storage and copy to another device and ask with the same flow the other TPM to decrypt it, it won't be possible.
So it's basically one way, right?
Yes.
Yeah. Okay, Lucas?
Povilas.
Yeah, I'm wondering if you're relying on the that TPM, like not TPM, but on your basically flash or something USB to use as your key. What happens if you lose it? What are like mitigating factors? Like, so I wouldn't get locked out if I accidentally like my keys disappear.
Actually, that's a good question. For now, like you, as far as I know, I may be mistaken, for example, but like in Google, it is a better option, and you have like to have a regular login to your account and then enable it as a second factor. But when you enable it as a second factor, it becomes the first, but like your previous registration doesn't disappear. As far as I know, you can't just right now register with the passkey. And in case you will be able to...
You probably lose the entire security.
Actually, yes. It's...
Okay.
You have, like, there should be some, like, ways to revoke your keys, like, to see the devices, if for example, your passkeys are shared, on which devices you can revoke a device from your management console, etc., etc. There are some extra layers on that.
Okay, thank you.
Okay, any other questions? No. So the main takeaway, use passkeys or not use passkeys?
So, now I'll continue. Actually, in my presentation here was the slide questions, because we are finished about the passkeys and one-on-one, but it's not the last slide of my presentation. But it was replaced by Q&As. So there are like 2 slides here. As of September of 2023, almost 99% of devices support WebAuthn, and that like the dark blue color is support of WebAuthn protocol on a platform, like on an operating system or in a browser. Like the middle blue is support for integration with the operating system, for example, TPM, Apple Keychains, etc. And the lightest blue is support for flawless user experience, when like you have to do minimal interaction apart from confirmation that use my key. For example, I open Google.com, he already knows my account, he like does all the things, just prompts me to like confirm that I want to log in there. So there is very little, but it is a huge gap. But the main idea is 99% of the operating systems and browsers already are aware of the BelFan. And the second thing is like here on the mobile devices, passkeys are synced or transferable mostly. It's upper pie with the light color. And on desktop devices, it's vice versa. And for example, like on macOS and Safari, it's like most probably will be ported to your iOS and Safari combination because of the Apple Cloud keychain. For example, on Windows and Edge, with Windows Hello, it won't be transported anywhere because maybe on Chrome, but that's all. Same goes with the, at least on my macOS, with the Firefox, they don't interact. Like macOS doesn't allow Firefox to access the keychain. So it's like bound on an inner ecosystem of the manufacturer. And since Google is the board member, like Chrome sometimes performs better than any else, like Firefox, Opera, Edge, etc. And here is the slide Marius asked. Yes, look for the passkeys and use them.
Okay, thank you, Mindaugai. Thank you for amazing presentation. If you want to deep dive into it, as Mindaugas mentioned, we have Cybersecurity Academy and how the authentication works, etc.
There are quite few good lessons and topics.
Yeah. And with that, I would like to say that thank you for all the guys who attended the Tech Days. Thank you for all the guys who prepared it, especially for the presenters. Thank you guys who watched us online, and special thank you I have to our team that worked here. It is UAB Mobili Media. Hey, Eimantas, Rokas, Ignas, August, and of course, especially our event team. Evelina and Monica. Thank you very much. And hope to see you on summer session. Please apply. And let's geek out together. Cheers. Ciao.